Hello, and welcome to this Advanced React course that continues from the React Basics course in this specialization. Throughout this course, you'll learn more advanced React concepts. Let's take a moment to review some of the key concepts and skills that you'll learn. In the first module, you'll start by learning how to render and transform lists in React and work with forms. In this process, you will be introduced to the map method to perform transformation operations and render lists of components. Then, you'll learn about identifiers called keys, which are an integral component in list transformation in React. You'll dive into controlled components with a focus on creating a controlled form component in React and implementing your own feedback form. And you will revise what you know about props and state, exploring React context as a viable alternative to local state in certain situations. You can also look forward to working with practical examples using the Context Application Programming Interface, or API, to manage global state in your React apps. In Module 2, you'll gain an in-depth understanding of hooks. This includes learning the use and purpose of React hooks, the rules for using hooks in React, and how to build custom hooks in React. For example, you will learn about the purpose of the use state, use effect, and use reducer hooks and how to use them. In the third module, you will be introduced to a variety of more advanced concepts related to JSX, as used in React, such as components and elements. You'll explore the types of children within JSX, discovering the importance of component composition and the children prop, how to manipulate children in JSX, and the spread operator in React. You will also be introduced to the process and purpose of creating higher-order components and render props, starting with an introduction to cross-cutting concerns. Another important topic that will be covered is performance in your React apps, as well as testing and debugging your application. Plus, you'll learn about writing integration tests using the React testing library with a focus on testing the behavior of forms and exploring practical applications of tests. During these modules, you'll work through practical examples of theoretical concepts based on a restaurant called Little Lemon and encounter activities to test your knowledge and skills. And in the last module, you'll have the opportunity to demonstrate some of your learning and your practical advanced React skill set in a lab project where you'll code your own portfolio app. You'll also demonstrate your knowledge of these topics in a graded assessment. Well, I hope you're as excited as I am to work through this React Advanced course. Let's get started.
The keyword React is more popular than words like orange juice and renewable energy. And so it has been a framework that is very widely popular, and it's something that a lot of jobs now require when they're hiring new engineers. My name is Murtada. I'm a software engineer at Meta based in the Seattle office. So just about everything I've built in my career at Meta has been built in React. So, if you're using any of the Meta products, whether you're using Facebook or Instagram, most likely the buttons and the menus and the clicks that you're making are all events and components handled by a React framework. And that has been my career at Meta has been developing these kinds of components. So whether you're using it on a web, if you're going and posting a photo, or if you're making a comment, all of those interactions are powered by React components behind the scene. Well, I think personally, when I first discovered React, I was like, oh my God, this is so cool. And it just made building web applications so much easier. So it really simplified my job as an engineer to write using this framework. And it's very intuitive. It's much less error prone. So if we look at the trends we see in 2018, React actually rose up and exceeded what previously was the most popular web framework, which was known as jQuery, and React became the most searched keyword. So it makes sense for it to replace some of these older frameworks that are not keeping up with the speed of the industry. So the main language that's used to create React components is JavaScript, and there are actually different flavors of JavaScript that can be used with React. So At Meta, we use a flow flavor of JavaScript, and that allows us to ensure type safety throughout the use of developing React components. But there are other ways that React components can be built. Perhaps a popular way that is common in the industry is using TypeScript. And besides these different ways to use React components on web, you can actually use React to develop mobile components on like Android and iOS. And most recently, React is releasing a way for developing VR components like virtual reality, where people can use these same frameworks consistently that are used in web and mobile to develop virtual reality applications. The idea is to simplify it and allow developers to create complex virtual reality applications, but leverage the simplicity and friendliness of React. And that's what has given the motivation to create these different frameworks of React across different segments of the industry. At this point, it's an integral skill that just about every job and every application you build will probably require. So having this knowledge will really help you throughout your career, and it's going to also make your life easier to learn how to use such framework. So my advice to you as you venture into this world of React is to stay consistent. It may at first seem a little complicated or overwhelming, or some things may not make sense, but just power through it. It will make your life a lot easier to learn these principles. They'll make you much more attractive to employers in the future, and your ability to produce scalable web applications will be much better with the use of this framework. So keep going and don't let some of these confusing parts of React slow you down.
So you're ready to start programming with JavaScript. But before you can begin developing projects with JavaScript, you need to set up software called VS, or Visual Studio Code. VS Code is a code editor that developers use to write their JavaScript code. By the end of this video, you'll be able to install VS Code, Node.js, and the Code Runner extension on your Windows operating system. Start a new JavaScript file in VS Code and run the file using Code Runner extension, and explain what console.log does in JavaScript. Let's begin by exploring the VS Code download and installation process. First, I open a search engine in my browser and search for the term VS Code, or Visual Studio Code. I click on the first link, which directs me to the official website at code.visualstudio.com. This link redirects me to the site's homepage. On this homepage, I select the Download for Windows button. A message appears on the VS Code website which states, "Thanks for downloading VS Code for Windows." I can then track my download progress in my browser. Once the file is downloaded, I click the file to begin the installation process. The license agreement appears. I read through the agreement and select Next. I then accept the default installation destination and the Start menu folder. I also select the following additional tasks: create a desktop icon, add Open with Code action to Windows Explorer file context menu, add Open with Code action to Windows Explorer directory context menu. Once I've selected these additional tasks, I click Next. Now that I have configured these tasks, I select the Install button. Once installed, I then check Launch Visual Studio Code and select Finish. My Visual Studio Code program then appears in a new window on the Get Started page. From here, I click the bottommost icon on the very left of the VS Code window to open the Extensions panel. Once in the panel, I type Code Runner to search for the Code Runner extension. I then select and install this extension from the search results. While the extension installs, I return to my browser and search for Node.js. I access the file from the official site at nodejs.org and click on the direct download link, making sure to install the Windows version. A pop-up appears on screen to track progress of the download. Once the file has downloaded, I select Open File to open the Node.js setup wizard. I then select Next and accept the license agreement. I then click Install to begin the installation process. Once the installation process has completed, I click the Finish button to close the setup wizard. I then return to VS Code, where the CodeRunner installation process is complete. To confirm that CodeRunner is installed, I can check for the following message on screen, which states, "This extension is enabled globally." Just to the right of the CodeRunner tab is a stripe for the files. I double-click this to open a new file. I then click Select Language and choose JavaScript from the list of languages. I can also type JS in the search bar to narrow my results. Next, I close the CodeRunner tab and click on the Extensions icon to toggle off the extension sidebar. I then click on the View tab and select the Terminal option to open the terminal that I closed earlier. I need to clear the terminal. I can do this by typing Clear and pressing the Enter key. Next, I hover over the terminal's Output tab. I then click, hold, and drag it to the right in order to dock it on the right-hand side of the VS Code window. Now, I close the terminal again. The output should remain on the right-hand side of the screen. I can also adjust the width of the output by dragging the split to the left or right. Finally, I type some code into the tab Untitled 1 as follows: console.log, followed by a pair of parentheses in which I type "Hello World" in single quotes. To run this code, I click the play icon. I can also use the shortcut keys Ctrl-Alt-N. The words "Hello World" appear in my output. Other information also appears, but "Hello World" is all I need to focus on for now. And that's it. I've successfully set up VS Code with CodeRunner. You now know how to install Visual Studio or VS Code, Node.js, and the CodeRunner extension on your Windows operating system. You can also start a new JavaScript file in VS Code and run the file using CodeRunner extension. And you can explain what console.log does in JavaScript. Great work.
You need to lay things out, and it's very difficult if you don't have CSS grids. Take one and... Oh, I'm having fun now. I'm Benedict Hobart. I'm a front-end engineer at Meta. Bootstrap is a very popular CSS framework, CSS library used to help quickly build websites. It has a lot of primitives that you'll commonly need when styling buttons or styling rows or styling grids. And then there's grids, which is a CSS layout spec that allows you to lay items out in a grid, which was previously a very complicated task. I know it sounds simple, but you can say, I want this item to be at this part of the grid and in this row and in this row. And helps you make more responsive apps as well. I learned about it years ago, I think probably in 2017 or 2016, and there is a whole class of layouts that are much more easily solved by grids than by previous layout approaches. You need to do a lot of computation in JavaScript to know the widths and heights of images and where to put them and how to get them to lay out at the screen. But if you've got CSS grids, it's just one line of code to then get things to lay out in a performant way that's responsive and reliable. Generally, you put a bunch of different layouts together when you're building a website. So you might use a grid spec in one spot, say in a table-based layout that you want to be responsive. But then you might use another layout that contains a grid and wraps it. And it's important to learn how to lay out items so you can build an app and define its layout in a flexible way. So being able to say, I want this to appear at the bottom of the screen when it's a footer, or appear as a tab bar at the top of the screen. I think there's a number of reasons you want to learn how to do it. I think most websites could be reduced to a grid. Knowing one layout and how one layout works in detail allows you to take that knowledge to easily learn future layouts that you might want to build. Starting off with one and getting a good grasp of that is a really good foundation to let you learn other layout engines. And if you ever want to move beyond web into iOS and Android, they've probably got their own layout engines that they use. I hope you develop a good understanding of how to use grids in your app. and how it can be useful. I hope you understand that it's just one thing in, a broader set of layout specs that you can use in the browser. And I guess more importantly, I hope you develop a strong foundation here that you can take into your great career and learn other layout specs and how to build the next generation of apps.
How many times have you found yourself browsing apps? Maybe you've used an app to order food, scrolling through different menus, hoping to find what you'd like. Well, lists like this are common to almost every app, which is why it's important that you know how to manipulate them in JavaScript. Chances are you'll need to transform various elements before displaying the final list to your users. So in this video, you'll learn how to use the map method in JavaScript to transform lists of data. Let's imagine that a restaurant called Little Lemon would like to display a list of its popular desserts. Remember that a list is a simple collection of elements, which translated to JavaScript terms represents an array. These arrays can contain any type of data, but the most common type you'll encounter per element is an object. Now, say Little Lemon uses an external service to query a list of its most requested desserts by users. However, when fetching data from a third party like this, you are generally provided with more data than you need, and the data will be provided in a format or shape that is determined by the third party. This means that you may need to write more code to handle the data in order to retrieve just the information you need. That's where the map method comes in, as a way to ignore everything that you do not want displayed on screen and extract only the data that your users care about. So let's explore how to transform this list of dessert items using the map method in JavaScript. In JavaScript, when you deal with lists of items of any kind, you need to use the array type. JavaScript offers different methods that you can use with arrays to perform various operations. In order to perform a transformation operation, you must use the map method. Coming back to Little Lemon, imagine you have a list of its top requested desserts encompassed in a variable called data. Each dessert has the following properties: ID, title, image, description, and price. In this case, you would like to show a very simple list of desserts with a property called content, which you can create by merging together the title and description and the price of the delicious dish. First, I'm going to define a new variable, since the map method always returns a new array. Let's call this new array top desserts. Next, I'm going to apply the map method to the original data array. For now, I'll return the data as it is, so you can examine the basic structure of a map transformation. I would like the new items to have two properties. The first is content, which is going to be a combination of title and description. Let's use a dash character to separate the two. Secondly, there's the price, which I will pass as it is. Last, I will console log the result to demonstrate that the new list I have created contains the shape or format that I originally intended. And here's your transformed list. You just learned how to transform data in JavaScript with a map method. This is a simple yet powerful tool you will find yourself using quite often when dealing with data from an external provider. Your users will thank you when they experience how easy it is to navigate and consume information in your apps. Did you know that with React, you can transform any list of items into a collection of React components? So, drawing upon the previous example of Little Lemon's list of desserts, imagine the restaurant would like to go one step further by providing its online visitors with a sneak peek at the best desserts in a dedicated section to encourage them to order. Well, in this video, you will learn how to display a collection of elements like this with React by using the map function and JSX syntax. Recall that JSX is a special syntax extension to JavaScript that React uses to describe user interfaces, or UIs, and that a component is a function that returns JSX. Now, let's explore how to render a list of elements with React. In this demonstration, I will use the list of Little Lemon's best desserts again, each one having the following properties: ID, title, image, description, and price. The aim is to display a simpler version of this collection of top desserts by displaying just the title and the price. The first step is to create a new variable called list items to store the result of the transformation I am going to perform. For that, I am going to loop through the array of desserts using the JavaScript map function. You may be wondering what I should return inside the map function. Traditionally in JavaScript, you would return any data type. When you are working with lists in JSX, you can also return a React component as the transformation applied to each element. You will discover how that's useful later on, since you will be able to embed the result directly into the return JSX. Recall also that all HTML tags are components by default, so you can leverage all the semantic tags you already know from HTML. For list items, your best choice is the list item or LI semantic tag. I am going to return an empty list item for now. Because the goal is to display the title of the dessert and its price, I am first going to create a new variable for the text named item text. I will use a dash to separate title and price, as well as the dot notation to access the needed properties from the dessert object, which are title and price. Since this is a JSX transformation that will be part of the render method of this component, you have to use curly braces to wrap your data. In this case, the text for each list item, which is the value of our variable item text. The last step is to go to the render method and embed list items into the HTML list wrapper component, unordered list or UL. And that's it. The desserts are displayed in a simple and concise way. This addition will certainly help Little Lemon restaurants to increase its orders, so well done. You have learned how to transform collections of elements with React by using a combination of the map function and JSX curly braces. With lists being one of the core building blocks of app development, you're now one step further in your journey to creating great apps. One important advantage of using React is its ability to automatically optimize updates in your user interfaces or UIs. If React was a plane, it would use autopilot mode in most cases, letting you relax in the driver's seat. But even with autopilot, you'll need to take action sometimes, like for example, performing a specific maneuver to land the plane. The same is true for React, as there are scenarios where you, as the developer, will need to take extra steps to specify how React should behave when your UI changes. In this video, you will explore how to use keys as a way to do so when dealing with lists of elements. You will learn how to use keys to identify and distinguish elements in a list, how to determine the right key for your list items, as well as what using keys incorrectly means for your app's performance. Because React is fast by default and designed with out-of-the-box performance in mind, you usually don't have to think about updates in your UIs. When computing a change, React applies its diffing algorithm to calculate the minimum number of changes that are necessary to perform an update in your tree of components. Although this algorithm works perfectly most of the time, as mentioned earlier, there are some cases where React can't make important assumptions to find the most optimal path for an update, which means the developer will need to step in. Let's explore one such example. Imagine the drink section in the Little Lemon online menu, where restaurant managers can add new drinks depending on the season. When they add a new element at the end of the list, the diffing algorithm works well, since React will match the two beer trees, match the two wine trees, and then insert the cider tree. However, when inserting a new element at the beginning of the list, the algorithm offers worse performance because React will mutate every child instead of realizing it can keep the beer and wine subtrees intact. This inefficiency can be a problem. To solve this issue, React supports a key attribute. So, what are keys? Keys are identifiers that help React determine which items have changed, are added, or are removed. They also instruct how to treat a specific element when an update occurs and whether its internal state should be preserved or not. To illustrate, adding a key to the last example can make the tree conversion efficient. That's because React now knows that the element with the key cider is the new one, and the elements with the keys beer and wine have just moved. The general rule of thumb with keys is to use a stable identifier that is unique among its siblings. This allows React to reuse as many elements from the list as possible, avoiding unnecessary recreations, especially when their content is exactly the same and the only thing that has changed is their position in the list. The key used most often is a unique ID that comes from your data. Those IDs typically mirror a database ID, which is an ID given to an item in a database that by nature is guaranteed to be unique. But what happens in cases where your data doesn't have any suitable ID or you are rendering a list that is not dependent on any server data? In these scenarios, you may think that generating your own unique IDs is sufficient, whether you do so via an external library or with a randomizer function like the built-in math.random function. However, while that approach will indeed avoid any collisions in your keys, meaning that it will not produce two keys that are the same, it will not preserve the internal state of your list items. This is because when a re-rendering occurs, those keys will be different, resulting in React having to recreate your list from scratch. As a last resort, you may use the item index. Since it determines the position of each element in the list, it guarantees the absence of duplicates. But indexes are not recommended for keys if the order of items may change. For example, in cases where your list has sorting capabilities or users can either add or remove items. When used incorrectly, keys can negatively impact performance and may cause unexpected glitches in your UI when updating your lists. That's why it is very important to make a conscious decision about your keys implementation. You have now been introduced to keys in React and how to use them when dealing with lists of items, such as using keys to distinguish between list elements, choosing the right key, and the effects of incorrect usage of keys on app performance. A primary takeaway is to always use a key that is guaranteed to be unique among its siblings, so use unique IDs from your data when possible. You can use indexes as a last resort, but don't forget that this approach will not work when the order of your list items is prone to change. Next up, you'll have the opportunity to explore using keys within list components in practice. Bye for now.
In this video, you will learn how to use keys correctly within list components in React through a practical example. Imagine that Little Lemon restaurant managers would like a separate application that keeps record of the tasks they need to do. In order to do that, I have built a very simple to-do list app with two different editable to-dos that are represented via text inputs, as well as a button that will reverse the order of the to-dos. I will start by walking you through the code example I created previously with Create React App. The to-do component is basically a table row which has an ID, a text input to type a value, and a date of creation. Both ID and created at are passed as props, whereas the input value state lives in the DOM node. In other words, the text input is an uncontrolled component. The main app component encompasses the whole interface displayed on the screen. The to-dos data model is a piece of state which is essentially an array of objects where each object contains an ID and a date of creation. Then, there is the reverse order function, which effectively changes the order of the to-dos. The reverse method from arrays is a mutative operation. That means that it modifies the original array rather than a copy. To avoid mutating the React state, which is something you should never do, it's important to make a copy of the array first, which I'm doing by using the ES6 spread operator. Finally, when it comes to the JSX for the user interface, there is a wrapping div, a button to reverse the order of the to-dos, and a table, where each table row is a to-do task. Each to-do instance receives an ID and created at as props, which we are passing from the data model. Now coming back to the app, the first thing I'm going to do is to open the browser console. A warning in red is displayed. When you're running your application in development mode, React does a great job of providing solutions to potential problems in your applications via contextual warnings as console errors. The warning clearly states that each child in a list should have a unique key prop and that I need to check the render method of the app component. The index position of the to-do item fulfills the requirement that the React warning is asking about, so I'm going to use that. Okay, now when I reload the application, the warning disappears. However, I haven't tested the application yet, so let's type some to-dos and explore what happens when I reverse the order. For the first one, I will type stock take, and for the second one, process payroll. Now I would like to reverse the order because the managers should do payroll first. Oh, that didn't work now, did it? The text inputs have not moved, but everything else has. Well, you have just discovered one of the main problems when using indexes as keys when the order of your list items is prone to change. So what exactly is happening? If I go back to the code and take a look at the JSX for each to-do, when I reverse the order of the to-dos, the ID and created at prop have changed, but the key is still the same because I'm using the index. Since it's the same, React is instructed to keep the internal state of that node. That's why the input state from the to-do is preserved. Now, how do you fix that? Coming back to the key requirement, it has to be something unique but that correctly identifies each to-do, no matter what its position is in the list. In this case, I can definitely use the ID property from the data model as my key. After all, that is guaranteed to be unique per to-do. So now I'm going to implement that change and I will run the previous test again by clicking the button one more time. Great, this time it worked as intended. You have learned about choosing keys in your React code. You will come across collections of elements quite frequently, and with your knowledge of keys, allowing your users to do the tasks they want to complete first won't be a problem anymore.
When browsing the internet, there's a big chance that you'll land on a form, even without you realizing it. From simple email inputs and subscribing to newsletters to more complex forms, such as creating an account on your favorite social media platform, forms are everywhere. So you'll probably find yourself implementing them in your applications regularly. In this video, you'll learn the concept of controlled components in React and how they are used in form processes, the fundamental concepts of HTML forms, and how forms can be created as React components. When it comes to React applications, HTML forms work differently to other DOM elements. You may recall that the DOM is a logical tree-like structure representing the HTML document, and it uses nodes to describe the various parts of the document. Traditional HTML forms keep some internal state inside the DOM and have some default behavior when submitting them. That's normally done via the action attribute, which points to the endpoint that will handle the request. But what if you would like a more granular level of control? For example, customers of the Little Lemon restaurant can reserve a table on the website using a form. Imagine if there was a function that could handle the submission of the form and access the data that the user entered into it. That's where controlled components come in. Controlled components are a set of components that offer a declarative application programming interface, or API, to enable full control of the state of form elements at any point in time, using React state. Rather than relying on the native state from DOM elements, the React state is made the single source of truth, controlling the displayed value of your form elements at all times. The way you perform this state delegation is via the value prop. Value is a special property that React added to most of the form elements to determine the input content at any point in time during the render lifecycle. So, in order to create a controlled component, you need to use a combination of local state and the value prop. Initially, you assign the local state to the value property. But how do you get updates from any new text character entered in the input? Well, for that, you need a second prop to complete the design of your controlled component, the onChange callback. The onChange callback receives an event parameter, which is an event object representing the action that just took place, similar to events on DOM elements. To get the new value from every keystroke, you need to access the target property from the event and grab the value from that object, which is a string. Finally, to have control over the form values whenever the form is submitted, you can use the onSubmit prop in the form HTML element. The onSubmit callback also receives a DOM-like event as a parameter. There, you can access your form values to perform any desired logic that must take place before submission. For example, validating your input values. Also, if you would like to prevent the default HTML form behavior, you need to call event.preventDefault inside your onSubmit callback. Well, there you have it. You have discovered a technique called controlled components that enables React to be the source of truth for the state of your form inputs. React offers controlled versions of the majority of input types and recommends using controlled components for the implementation of forms. However, keep in mind that there are still some form elements that remain uncontrolled, similar to their DOM counterparts. So, as you move forward with your learning, you will gain more insight into both controlled and uncontrolled form elements. In this video, you have learned about the concept of controlled components in React and how they are used in form processes. You also explored the fundamental concepts of HTML forms and how forms can be created as React components. Forms may look simple, but there are many different features and functionality to forms, and for developers, there is an art to constructing forms. React makes constructing and customizing forms much easier for developers, and that's why it's such a popular choice. Would you like to master the art of building forms with React? Well, there are some key concepts and features that you will need to learn to truly unlock the versatility and effectiveness of controlled components and forms using React. The Little Lemon restaurant online webpage was created some time ago. While Little Lemon were happy with the results for some time, they started realizing their users were having issues with their old contact form. After receiving some advice, they concluded that it needs to be rebuilt, and they have chosen React as the most suitable framework for the task, due to the ability to easily apply the features, functionality, and control that they require from the form. In this video, you'll learn how to help Little Lemon by creating a controlled component in React, using local state and the onChange event to update form inputs, avoiding the default behavior of the form submit event, and disabling the submit button when the form is not valid. Recall that controlled components in React are those in which form data is handled by the component's state, whereas uncontrolled components are those in which the form data is handled by the DOM itself. To gain more insight into creating form components in React, you will now examine the code of a basic form example. I am going to demonstrate the creation of form components in React using an app I constructed previously. In this example, the project has been created with Create React App. The return method of this functional component essentially has a form that contains two elements, a text input to type a username and a submit button. This form resembles a classic HTML version, so it'll work the same way whether you're using React or not. To test the application, I type John as the name and click on the submit button. By doing so, the default action of the form kicks in, which is a GET request to the root and a page refresh. In React, this current implementation is considered an uncontrolled form, having all the states living in the DOM. Let's work through the necessary steps to transform this form into a controlled version. First, I need to create some local state for the text input, which I'm going to call name. Secondly, I need to hook up that state to my text input via two props, the value prop to turn the input into a controlled one, and onChange to receive all the changes per keystroke and thus update the state of my input. Last, to control the submission of the form, I have to use the onSubmit prop in the form tag. For now, I'll log a basic message stating that the submission was successful to the console. Now, let's check if the form still works as before. I'll type a name and click Submit. And it's working. My message was logged to the console, and the default behavior of the form has continued on. Although this is great, I'd actually like to have more control on the submission of the form. In particular, I'm not interested in the default behavior of calling the root of the server and refreshing the page. You may be wondering how I can prevent that from happening. In traditional forms, you would do this by returning false from the onSubmit attribute. However, in React, the way to do it is by using the event property you get as a parameter in the onSubmit callback and calling prevent default on it. Now, when I submit my form again, no refresh happens and no server is hit with a request. Let's go one step further and clear out the input after submission. For that, I call the state setter with an empty string inside the onSubmit callback. Great! My form is taking shape. To demonstrate even more benefits of controlled components, let's perform an additional improvement by only allowing the user to submit the form when the text input is not empty. Disabling the button is as easy as using the disabled attribute. In this case, if name is an empty string, this expression would be evaluated as true and the button would be disabled. So in the app, I can't click on the button if there's no name provided. Finally, for best accessibility practices, let's connect the label with the input. I set an ID for my input, called name, and now I will connect the label. In traditional HTML forms, you would have to use the for property, but in React, for is a reserved word, so you must use HTML for and pass the ID of the input. Now, if I click on the label, its corresponding input is focused. And that's it regarding the basics of controlled forms in React. You have learned how to transform an uncontrolled form into a controlled version using local state and the onChange event, as well as the onSubmit prop and some of the benefits of doing so. In terms of form submission, you also learned how to avoid default behavior and disable the submit button when the form is invalid. Well done. You're making great progress.
Have you recently bought a product through an e-commerce site, or maybe you booked a table at your favorite restaurant? Well, if so, you may have received a friendly email afterwards providing a link to a specific page to provide feedback about the experience. This is an example of a feedback form. Now that you're familiar with controlled components in React, I'm going to demonstrate how you can build this functionality yourself. You will also be using a range input and custom validation as part of building a feedback form. Imagine Little Lemon, one of the best restaurants in town, would like to send their customers a feedback form. So let's go ahead and implement a feedback form with React. Note that in this example, the project has been created with Create React App. I have also added some initial code that is a form with just a header and a submit button. The requirements for this example are an interface that allows users to provide a score from 0 to 10, and an additional comment to tell the chef how delicious the food they enjoyed a few days ago was. The first step is to implement a control for the score. There are different ways you can do this, but I'm going to go and choose a range input for this use case, as it provides the user with a simple slider. To do this, let's go ahead and create a new div to wrap the component. This will consist of a label that I will name score, as well as an input whose type is going to be range. Range inputs offer two props to define the range, min and max. For this example, I will set the minimum to 0 and the maximum to 10. The application is now displaying a user-friendly slider to provide the score. To wrap up the range component, I need to do two more things: turn the input into a controlled component, and visually show the numeric value that represents the slider selection. For that, I will define a new piece of state called score that I will initialize to 10, because I know the chef's recipe is usually unbeatable, enabling the user to reduce the score down from 10 when they interact with the slider if they want to. Now in the range input, I have to use the value prop to hook the state up and use onChange to receive the changes and update the state accordingly. Since I also want the numerical score to be displayed with the slider, I'm going to add that information to the score label, along with a star so the user interface, or UI, is clean and concise. Great, the feedback form is starting to take shape. Now let's implement the second element from the form, a widget to provide an additional comment. Although I could use a text input here, a comment could be very large, so a more suitable choice is a text area. For that, I will declare another state variable named comment that will be initialized to an empty string. For the UI, I will create a new div with a label and a text area component for any additional feedback. Now that that is rendered well, I need to hook up the state to the value prop and update the changes via onChange. And with that, the UI for the feedback form is finished. The last thing I'd like to implement is some validation to ensure a comment is required when the score is equal to or lower than 5, and that it should have at least 10 characters, so the chef receives honest feedback from users that can be used to improve his recipe. For that, I'm going to use the onSubmit callback on the form component. I will call prevent default first to avoid the default HTML form behavior. Then I'm going to write an if statement to check if the score is equal to or less than 5 and the comment has less than 10 characters. If that's the case, I will show an alert to inform the user about the requirement and return from the function. Otherwise, the user is good to go, and I will log a message to confirm the successful submission of the feedback. It's also a good practice to reset the form values after submission, so I'll set both pieces of state to their initial values. And there you go. Everything is working well, and the submission message is logged into the console. You have learned how to build a feedback form with React using controlled components and custom validation to make sure users have a seamless experience.
Imagine that Little Lemon has been such a success that the restaurant will be expanding to other locations. As a part of the construction project, the architects have created blueprints with the kitchen and dining areas set to be identical in size. Although the blueprints have been defined, it will still be up to each restaurant manager to decide various things, such as the size, shape, and number of tables, type of chairs, kitchen crockery and utensils, and wall colors. In this analogy, the blueprints for the new locations are React components, whereas the specific configurations for each location are what React props and state represent. So, what are props and state? Props and state are both plain JavaScript or JS objects that React uses to hold information. As you progress through this video, you will discover the differences and similarities between props and state in React. You'll also learn how to identify whether something falls into props or state and when state is needed, as well as how to differentiate between different React components based on props and state. While both props and state influence the render output, they are different in one important way. Props get passed to the component, like parameters in a function, whereas state is managed within the component, like variables declared within a function. So even though props and state are inherently different, there are areas where they overlap. Notably, when designing a component, its main responsibility is to translate raw data into rich HTML. In the React ecosystem, the props and the state together constitute the raw data that the HTML output derives from. Both props and states are plain JS objects and are deterministic. This means your component always generates the same output for the same combination of props and state. Another similarity is that props and state changes both trigger a render update. Now, how do you know if something goes inside props or state? The rule of thumb is that if a component needs to alter one of its attributes at some point in time, that attribute should be part of its state. Otherwise, it should just be a prop for that component. Let's explore this in greater detail. Props, which is a shorthand for properties, are a component's configuration. They are received from parents in the tree and are immutable as far as the component receiving them is concerned. A component cannot change its props, but it is responsible for putting together the props of its child components. In addition to prop, React components have another built-in object named state. This object is a way to allow React to determine when it should re-render a component. React is set up so that any change to the values served in the state object will trigger a re-render of a given component. State's lifecycle starts with a default value when a component mounts, and then modifications of that value happen over time, mostly generated from user events. So state is a serializable representation of one point in time, or, in other words, a snapshot. A component manages its own state internally. You could also say the state is private. Now, another question you may ask when designing a component is whether it should have any state at all. Well, the answer is that state is optional. Since state increases complexity and reduces predictability, a component without state is preferable. Although you can't avoid having some sort of state in an interactive app, you should avoid having too many components with state. Finally, let's examine one of the main ways of differentiating types of React components based on props and state. Components can be stateless or stateful. Stateless components have only props and no state. There's not much going on besides the render function, and all their logic revolves around the props they receive. This makes them very easy to follow and test. On the other hand, stateful components have both props and state. They're in charge of client-server communication, processing data, and responding to user events. These sorts of logistics should be encapsulated in a moderate number of stateful components, while all visualization and formatting logic should move downstream into as many stateless components as possible. Well done! You've completed this lesson on the two types of data React uses to build applications, props and state. Going forward, you'll be introduced to an additional approach to managing information called context. In a typical React app, data is passed from parents to children via props in a top-down fashion. However, there are certain types of data that may be needed by many components within an app. In these scenarios, using props, which is what React offers us to pass data down, is not always effective. So in this video, you'll be introduced to an alternative way of passing data called context. You will learn more about what it is and why it was introduced and explore it in action. Let's imagine Little Lemon's food ordering app offers a light or dark theme that changes the background and text colors of all elements, or some general preferences, like a specific locale, depending on the visitor's geolocation, that multiple components should be aware of. And what do these pieces of data have in common? Well, they represent a global state for your entire application. Now, as your app grows in size, the same will happen with the tree of components your app is composed of. As mentioned earlier, props is what React offers you to pass data down, but in this scenario, they can be cumbersome since you will have to explicitly pass that data through every level of the tree, having intermediary components that don't really need the data and just act as a proxy. This issue is commonly referred to as the props drilling problem, and the name says everything you need to know about the problem. Parent components have to drill down props all the way to the children that need to consume them. The way React has solved this problem is by introducing the Context Application Programming Interface, or API. Context provides an alternative way to pass data through the component tree without having to pass props down manually at every level. It is the right tool when you need to share data that can be considered global for a tree of React components. Let's take some time to examine Context API in action. In this demonstration, I am going to use a simple app I created previously with Create React App. It represents a simple blogging platform that Little Lemon has to publish new, innovative recipes to its subscribers. It consists of a header that contains a title and the current user that is authenticated on the top right. The rest is rendered by the page component, which itself consists of the user blog entries, each one with a title, content, and author name. Note that there are two components that need to know the authenticated user: the logged-in user component inside the header and the page component. Because an authenticated user falls into the nature of global data that needs to be shared across several components, this is a clear example where context is the perfect tool for the job. So let's go ahead and create the needed context, which I'm going to call user context. Now, within the user context file, you must follow the next steps. First, you need to import create context from React. This is the function that gives you a new context object back. The function argument is the default value, which in this case I will declare as undefined since the app doesn't know beforehand who the logged-in user will be. Second, you need to create a provider component. To do so, I will call it userProvider and render the userContext.provider component. The userContext.provider component is what allows consuming components to subscribe to context changes. This component accepts a value prop, which is what will be passed to consuming components that are descendants of this provider. Now, for this application, the value prop should be the authenticated user, so I am going to define a new piece of state for it. Note that this is an oversimplification that already assumes a specific user, as in a real-world scenario, you will have to fetch the authenticated user first and then set it as state. You will learn about fetching data later in the course. All right, so now that the state is defined, I will hook it to the value prop. Next, it's necessary to provide a way for components to subscribe to the context. For that, I am going to create a custom hook that wraps the useContext hook, which is the way to consume a context value. This external function is created just for convenience, so there's no need to export the user context to external components. As a side note, don't worry if you're not very familiar with hooks yet. They will be covered in depth in future lessons. The user context is now defined, but the app is still not aware of it. For that, the provider component is needed. So I'll go ahead and wrap the whole app with it. The last step is to consume the user context in the places where the username has to be displayed, which are in the logged in user component and the page component. I'll go ahead and use the custom hook defined earlier, use user, and destructure the authenticated user from there. Finally, that information can be embedded in both render methods. The app now successfully displays the name of the authenticated user. Great work. You've learned about context and why it's used and worked through a practical example of how to use it. But keep in mind that although context is useful for global state, it's still recommended that you stick to props and state as much as possible. That way, your app data flow will be easier to follow. Well done. You've reached the end of this module on React components. Let's take a few minutes to review what you have learned so far. You began the module with a comprehensive lesson on how to render lists with React. You were introduced to the map method in JavaScript, which can be used with arrays to perform transformation operations and is a useful tool when dealing with data from an external provider that you'd like to display differently in your app. You also learned how to transform any list of items in JavaScript using the map method firsthand. Next, you discovered how to use that map method function along with JSX to render a list of components and transform a collection of elements with React. Finally, you gained an understanding of the concept of keys, followed by a practical set of guidelines that help you choose the right key depending on your use case. You learned that keys are identifiers that help React determine which items have changed, are added, or are removed, as well as instruct React how to treat a specific element when an update occurs and whether its internal state should be preserved or not. You also discovered that keys can be used when you need to provide explicit information that tells React how to behave when your UI changes when dealing with a list of items. You learned that the general rule with keys is to use a stable identifier that is unique among its siblings, which is why the key used most often is a unique ID from your data. You then learned that it is possible to use indexes as keys as a last resort, but that this can negatively impact performance if the order of your list items is likely to change. Next, you moved on to a lesson on forms and how React treats them differently compared to traditional HTML versions. You were first introduced to controlled components, which are a set of components that offer a declarative API to enable full control of the state of form elements at any point in time using React State. You learned how to convert any traditional HTML form into a React form using a set of controlled components. In other words, you learned how to transform an uncontrolled form into a controlled version using local state and the onChange event, as well as the onSubmit prop. You also discovered some of the advantages of controlled components compared to uncontrolled components. For example, it makes it possible for you to have more control over form submission, such as disabling the submit button when the form is invalid. Last, you were taught how to implement a feedback form, and in relation to this, how to perform any custom validation logic before the submission of the form occurs. The final lesson began with a recap of props and state. You learned to clearly differentiate between props and state and when to use one or another. Recall that although props and state have similarities, for example, they're both plain JavaScript objects that React uses to hold information, props get passed to the component, whereas state is managed within the component. Key takeaways included that if a component needs to alter one of its attributes at some point, then that attribute should be part of its state. Otherwise, it should just be a prop for that component, and that a component without state is preferable. You also learned about stateless components, which have props but no state, and stateful components, which have both. After that, you covered the problem of props drilling and how it affects your component's modularity, as parent components have to drill down props all the way to the children that need to consume them. You were introduced to Context API as a solution to this problem and discovered how to use it to encapsulate any piece of global state and avoid manually passing props down between components. The power of React Context was illustrated as a viable alternative to local state. Well, I think that's a fantastic start on your journey to mastering React. Looking forward to working with you in the next module.
Meta built studios for productions and virtual reality in New York City. And take, or what do you say? Take, what do you say? Action. My name is Murtada. I'm a software engineer at Meta based in the Seattle office. So React hooks were first introduced at a React conference, and it was shared with the community. And this is, the community of React enthusiasts who are excited about the new things. And they're the people that we trust to give us the feedback and test out the things that we're thinking about. I had gone on vacation and came back, and my coworker had been saying like, oh, there's this new exciting thing. Let's start using it. And I looked at it and I thought, this is so silly. Like, why do we need this thing? And he's like, no, trust me, this is going to be great. So I was like, okay, fine. And, I started learning them. I started using them. And now I can't imagine writing code without hooks. At first, it sometimes feels a little unintuitive, or there's like a lot of magic going on that doesn't make sense right away. But once you get the hang of it and you start using it and understanding it, it actually really makes life easier to use. Hooks can actually simplify your applications greatly and introduce performance gains. They can make your code more readable and easier to manage, as well as your code more shareable and reusable. And before the introduction of hooks, we were using class components, and they seemed like they were doing their job. But with time, these class components were becoming bigger. They were becoming quite complex. We couldn't really break certain components down into more modular components or pieces. We wanted to make code more usable. We wanted to make it simpler and remove this need for having these huge bloated components that were not able to be broken into smaller pieces. When we develop new technologies at Meta, we try to be the first users of those things to make sure they actually work, and we get to be watching the feedback as it comes directly from our engineers. So the same thing with hooks. We started actually using them internally a lot. And we saw that internal teams are also starting to really appreciate the improvements that Hook introduced. And so that really justified that hooks are making a big difference in the process of developing React applications, and it gave rise to rolling it out more widely. So when hooks were introduced, they were actually introduced in a non-breaking way, which meant that you don't have to use them. You could continue to use the old style of writing React components, and they didn't break anything that was previously written. And this is one of the approaches that we use when we roll out new things, is that we want to make sure this new thing doesn't break any of the old things that people were doing. And my advice for you as you're learning hooks and working with them for the first time is to stick it out. They may seem hard and confusing at first, but they actually will improve your code with time. And it may be tempting to use the old way of writing React code, but actually with hooks, you will find that once you learn them, code will make more sense with hooks, even if at first seemed a little confusing and intuitive. So take the time to learn them, make that investment up front, and you'll find that it's worth it in the long run.
Imagine that Little Lemon needs a way to track the restaurant's food inventory. In this video, you'll work through some practical examples using an app built for Little Lemon to revise the useState hook and explore how the useState hook is invoked. You'll examine the return values of the useState hook and how it's used to update state. You are probably already familiar with the useState hook, which is used to work with state in a React component, with state being all the data an app is working with at a given time. But before moving on to useState, let's revisit the concept of array destructuring. Recall that array destructuring is a way to get individual items from an array of items and save those individual items as separate components. Now, let's explore this concept with a practical example. Say you're coding an app that tracks current food reserves in Little Lemon's pantry. You're using a variable to keep all the veggies in an array. As you continue to code, you realize you need to get each item from the array into its own separate variable. For the first item in the array, you want to name the variable v1, as in veggie 1. The second item, v2, and so on. With array destructuring, you can do this easily using a single line of code. For more information on array destructuring, you can refer to the additional resources at the end of this lesson. Note that with array destructuring, you're free to give any variable name to the items that you destructure from an array. However, when destructuring objects, you have to destructure a property of an object using that exact property's name as the name of the destructured variable. This makes objects a lot stricter in terms of what you can name your destructure variables. For that reason, React uses the array data structure for the useStateHook's return value. Now that you've had a sneak preview of the return value of the useStateHook, let's explore how it actually works. I will demonstrate how to update state in React apps by using the useStateHook to set the initial value of the restaurant name to lemon, and then using only the useStateUpdating function to update it to Little Lemon. The useStateHook allows you to work with state in components. Let's start discussing state by revising what happens when I call the useStateHook. I'm only returning null from here because I want to focus on the console for now. Inspecting the console, this is what gets logged. The console logged value is an array, with the state variable's value being the first item in the array. The second item in the returned array is the function that will be used to update the state. So the useStateHook invocation returns a two-member array. The convention is to name this state updating function using camel case. Another convention is to name it by prepending the word set to the variable name used for the destructured state variable. In other words, the correct way to work with state means that my starting code example should be improved to correctly destructure the array returned from the call to the useStateHook. Now, the destructured restaurant name variable holds the state, and the destructured set restaurant name variable holds the state updating function. This is an example of array destructuring using the useStateHook. You may be wondering how you can update state. Well, when first starting to use the useStateHook, some developers try to update the state variable in a variety of ways. But there is only one correct way to update state when using useState, and that's through the state updating function. In other words, the only way to update the state of the restaurant name variable is by invoking the setRestaurantName function. In a React app, state changes are usually triggered through the act of a user interacting with the app. This means that state changes are usually triggered by user-generated events. These events, such as mouse movements, button clicks, and key presses, happen all the time in an app. The role of a developer is to respond to specific kinds of events in a way that's meaningful to the app that's being coded. One common way users interact with web apps is through button clicks. So let's examine an example of changing state in response to these user-generated events, namely button clicks. In this example code, I'm adding a button which, when clicked, will execute a function. This function is updateRestaurantName, which is invoked wherever a user clicks on the button. Now, when I click the Update Restaurant Name button, that will change the H1 heading from Lemon to Little Lemon, because the invocation of the Update Restaurant Name function triggered a call to the setRestaurantName state setting function. You should now be able to recall what the useStateHook is used for and how it works in practice. I hope that working with the useStateHook will be a fuss-free task for you going forward, especially when working with primitive data types to track state in a component. Imagine it's the very early days of Little Lemon, with the restaurant only existing on paper. The owner would like an app to track the development of their restaurant business and the achievement of all related goals. Let's explore how to build a goals app with the described requirements in React using the useStateHook in a component and updating the state. The completed app is now displayed on screen. When this code is compiled, I get a heading that reads My Little Lemon Goals. And then I have a simple form with two inputs, goal and buy. The first input field is there to let the owner type out their goal, and the second input field is there to let them type out the time frame within which they want to achieve a given goal. The code itself consists of three separate components: goal form, which captures a new goal using a form; list of goals, which loops over all the previously added goals and displays them as an unordered list of list items; and the app component, which puts those two components together and allows me to render them as well as pass the functions that they'll be working with through their props. Let's explore these. The first component, namely the goal form component, accepts the props objects. In the body of the goal form function, I start by declaring a state variable of form data, which is destructured from a call to the useState hook. I initialize this form data variable as an object with two properties, goal and buy, both assigned the values of empty strings. Next, I declare two functions, change handler and submit handler. First is the change handler function, which accepts an E parameter. This E parameter is a readily available event object. In other words, I don't have to pass this object from my change handler. It's provided to me by a mechanism outside of React. Even in plain JavaScript, whenever an event is fired, this creates an event object with many different pieces of data related to the event. I can then use this event object by simply assigning it a custom name, such as E, EVT, or even event. I'm using the letter E here to keep my code concise. In the body of the change handler function, I update the state of my form data variable by invoking the previously destructured state setting variable of setFormData, which was destructured from a call to the useState hook. The setFormData function accepts a shallow clone of the previous value of the form data variable. That's the form data variable with the spread operator before it here. Remember that you should not work with the form data variable directly, which is why I'm making a copy. This is because of how React optimizes its virtual DOM. Keeping state immutable makes it possible to compare a previous version of the virtual DOM with the updated version more efficiently and cost-effectively. Next, I update this new copy of the form data object by adding this code. It reads the eTargetName using the brackets notation, then sets the value of this property to whatever is inside that e.target.value property of the instance of the event object, which was built when that specific event was fired. The reason why this works with the brackets notation is that it allows me to set the value of the eTargetName dynamically. In other words, it allows me to set it as goal if the user typed into the input with the name attribute set to goal, or to set it as buy if the user typed into the input with the name attribute set to buy. Second, I declare a submit handler function, which also accepts the event attribute. The goal form component receives the prop named onAdd, and I'm giving the function addGoal to it as the prop's value. But it's not just any function. It's actually a function that's declared right here on line 43, inside the app component itself. This addGoal function accepts a goal entry and updates the value of addGoal's state variable that's kept inside the app function. It does this by adding this goal entry to the list of previous goals, saved and tracked inside the allGoals state variable of the app component. The update of any state variable must go through the previously destructured state updating function. In the case of the app component, this state updating function is the update all goals function. That's why I'm invoking this state updating function inside the add goal function. To make it all work, I also need to pass the add goal function definition to the goal form JSX element in the app component's return statement. That's why the addGoal function is now available as a prop named onAdd inside the goal form function. And that's why I can now use it inside the submit handler function starting up here on line 10. So I'm back in the goal form function declaration. Once the props.onAdd function is invoked here on line 12, it receives the form data variable, which triggers the update of the all-goals state variable in the app component as described previously. But now, I still have the form showing the values that the user entered. To deal with this, I need to reset the form data state variable to an empty string, both on the goal property of the form data state object and the by property of the form data state object. This now brings me to the return statement of the goal form function. Here, I want you to focus on the form element that has the onSubmit event handling attribute set to the submit handler function. The first and second inputs both follow the same structure of having the type, name, placeholder, value, and onChange attributes, which hook into the previously described functionality. Moving on to the list of goals component, this component receives the all-goals state variable as a prop from its parent app component. The purpose of this is to map over the all-goals array of objects, where each object holds the two properties that describe a single goal, as explained earlier. By mapping over the all-goals array of objects, I now output this unordered list with a list item entry for each individual goal. Having now worked through coding a goals app in React, you should have greater insight into using the useState hook within a component, including how to declare, read, and update state. Before moving on to using another hook, known as the useEffect hook, let's take some time to consider its name. The name of the useEffect hook is closely related to the concept of an effect, or more precisely, a side effect. In this video, you will learn what side effects within a React component are, including what pure and impure functions are and their relation to side effects, as well as how useEffect is used to perform side effects within functional components. So what is a side effect? A side effect is something that makes a function impure. Did you know that functions can be classified as pure and impure? Simply put, pure functions don't have side effects and impure functions do. Let's unpack the concept of pure and impure functions in relation to side effects some more. A pure function, should it receive specific input, that is, a specific parameter, will always return the exact same output, no matter how many times it gets invoked. To illustrate, let's explore a function that uses the year Little Lemon was established. In this example, the established year component accepts a props object, that is, a props parameter. It also returns a value, that is, a heading that outputs the words established year, followed by a colon, space, and the value of the year prop. As long as the value of the year prop is 2003, regardless of how many times the established year function is invoked or it is rendered from the app component, the output will remain unchanged. This is an example of a pure function. The established year function has no side effects. By contrast, an impure function will perform a side effect. That means it will do things such as invoke console log, invoke fetch, or invoke browser's geolocation functionality. In this context, a side effect can be thought of as something external to or outside of a function. Consider the example of a shopping cart function built for the Little Lemon app. It is an impure function because of the line that reads console log total. The console log call makes the function impure as it's a call to a browser application programming interface, or API. The shopping cart function now depends on something outside of itself, and even outside of the React app to work properly. So how should you deal with the issue of impure functions in React? Well, it's all about containing the impure actions inside their own special areas. To do this in React, you need to use the useEffect hook. Let's update the shopping cart component with the useEffect hook to properly deal with the side effect caused by the console log. First, you need to import the useEffect hook from React. The useEffect hook works by accepting two parameters. The first is a callback function. The second parameter is an array. This array can be kept empty, which is perfectly valid. While the syntax is valid, it's common to use an arrow function as the first argument of the invocation of the useEffect hook. Note that the useEffect has been simplified to a single line of code. It usually spans several lines of code. That's because it typically needs to do something more meaningful than just console logging the value of a component's variable. In this video, you learned about pure and impure functions and their relation to side effects, exploring what side effects within a React component are, and briefly how useEffect is used to perform them. You can look forward to applying this knowledge by using the useEffect hook introduced in this video to perform side effects. To demonstrate how to use the useEffect hook within a component, let's continue working on the Little Lemon app. Say the owner of the restaurant wants to add a specific way for the user to interact with the app. On a button click, the owner wants a welcome message displayed, and on another button click, the owner wants the message hidden. Additionally, the owner wants this change to be reflected on the Browser tab where the app is served. Updating a Browser tab is an example of a side effect. In this video, I will demonstrate how to do this by using the useEffect hook to perform side effects in React, as well as how to control when the useEffect function is run using the dependencies array. I am going to use an app I built previously using Create React App to demonstrate how to use the useEffect hook. To describe what's happening, let's start with a return statement. I have a wrapping div, and inside of it an h1, a button, and a JSX expression that uses the logical AND operator to conditionally render an h2. The button has an onClick event handling attribute, and it triggers the click handler function, which I've declared as a function expression starting on line 7. On line 5, I've destructured the toggle variable from a call to the useState hook to track the state of the toggle variable and make the conditional rendering in the return statement possible. Now let's inspect my app in the browser as it's currently being served. Everything is working well. When I click the button, the sentence "Welcome to Little Lemon" appears under it if it wasn't shown previously, and vice versa. Although the app is working well, my app currently has no way of updating the text in the Browser tab like the restaurant owner wants it to do. This is an example of a side effect, which is why the correct way to add this functionality is to use the useEffect hook. So, above the return statement, I'll add a call to the useEffect function as follows: react.useEffect. I need to pass a function to the useEffect call, so I'll add an arrow function without parameters, and in the body of the arrow function, I'll add this ternary here, which checks if the value of the toggle variable is true or false. If it's true, it should return the string that reads "Welcome to Little Lemon." Otherwise, it should return the string that reads "using the useEffect hook." Whatever gets returned is the value I'm assigning to the title property of the document object. This property thus dynamically updates the text showing on the tab of the browser where this React app is served. Let's inspect the updated app in the browser. I can confirm that with every click of the button, the title on the tab is updating to one of the two specified strings. So imagine that the owner has changed his mind and he wants the title on the document to be set on the initial component render. After that, he doesn't want it updated. This is where the dependency array comes in. The dependency array determines when the useEffect hook will be invoked. For now, I'll update my code with an empty dependency array, meaning I'm not tracking the state of any state variables. In other words, regardless of what is happening in my app, I don't want the useEffect hook to be invoked. This means that it'll be invoked only once, and after that, no matter what happens in my app, the useEffect hook will no longer be run. Now that I've updated my app, let's save the changes and examine how this affects the behavior of my app in the browser. The useEffect hook runs only once, outputs the words using the useEffect hook, and after that, regardless of how many times I click on the toggle message button, there are no further updates to the tab title. The dependency array is there to watch for changes to a specific variable, and based on that, execute the function that's passed in as the first argument of the useEffect function call. This means that if I want to run the useEffect hook whenever there's an update to the value stored in the toggle variable, I need to add the toggle variable to the dependencies array. After this change, back in the browser, the useEffect hook will be run every time the toggle message button is clicked, because the click handler updates the value of the toggle state variable by invoking the setToggle function. This, in turn, triggers the useEffect invocation, since the dependencies array is set to watch for changes to the toggle variable's value. And there you go. I have a way to fulfill any of the restaurant owner's requests that might involve some side effects in my React apps. You should now have a better idea of how to use the useEffect function to handle side effects and of how to use the dependency array to determine when it will be invoked. By now, you should have a fairly good idea about the purpose and functionality of hooks in React, and you may have even started using hooks in some of your solutions. If so, you may have encountered some cases where hooks might have made your code invalid. Well, that's because there are a few basic rules to hooks that you need to be aware of and follow in your React apps. In this video, you will learn all about the rules of hooks in React and why they are so important, and why you would only call hooks at the top level and from React functions. The 4 main rules of hooks are as follows. First, you should only call hooks from a React component function. Second, you should only call hooks at the top level of a React component function. Third, you are allowed to call multiple state hooks or effect hooks inside a component. And finally, always make these multiple hook calls in the same sequence. Now, let's unpack each of these rules in a little more detail. The first rule means that you should not be calling hooks from regular JavaScript functions. Instead, you should only call them from inside a React component function. From a built-in hook call, for example, from the useEffect hook, or from a custom hook. In this example, the code describes a button that can be clicked to pick up a new name for a pet. The name looper function is used to limit the pet name choices to only Fluffy, Rexy, or Gizmo. Notice that the useState hook is accessed at the outermost scope of the app function. It has not been used anywhere other than this, for example, inside the name looper function scope. However, you may have observed that this rule does not prevent you from using the state setting function, which is named setPetName here. State setting calls can be used wherever required. The second rule means you must call your hooks before a return statement, outside of loops, conditions, or nested functions. If you use a hook in a condition, you're breaking rules. For example, here the useEffect hook has been used inside the if conditional statement. That makes the use of the hook in this code invalid. The third rule is straightforward. There can be multiple hook calls, as long as they are always in the same order. What that means is that you cannot place hook calls inside conditionals, because that might result in an invocation of a hook being skipped when compared with a previous render. In this example, with the same code that describes a button that can be clicked to pick up a new name for a pet, the useState hook has been used incorrectly. Rather than using the state setting function, setPetName, inside the name looper function, the useState hook has been used here instead. If you were to compile the code and run the app, you may find that the expected output is returned. For example, I'd like to name my pet Fluffy with a Pick a New Name button rendered beneath. However, as soon as you click the Pick a New Name button, you would receive an invalid hook call error. That would violate the fourth rule. In other words, it might disrupt the sequence of invocation from one render to the next. Such a violation would result in errors. If you want to call an effect conditionally, you can still do so, but make sure to place the condition inside the hook. Here, the useEffect hook is invoked initially, followed by the if conditional statement. So now you're not breaking the rules, and the code is valid. So let's recap on the 4 main rules of hooks. You should only call hooks from a React component function. You should only call hooks at the top level of a React component function. You are allowed to call multiple state hooks or effect hooks inside a component. And finally, always make these multiple hook calls in the same sequence. And that's it. In this video, you learned the main rules of using hooks in React and why you would only call hooks at the top level of and from React functions. As long as you stick to these few simple rules, you can enjoy using hooks in your React solution successfully. The fetch function is a very useful tool, but there are some important things that you need to understand before you start using them. Initially, it's good to get an overview of how JavaScript delegates duties so that you can gain insight into how the fetch function contributes to this process. In this video, you will learn how the fetch function works to retrieve data from the web, and how to provide an example in plain JavaScript of the process. Fetch is used to make a server request to retrieve some JSON data from it. Fetch API is a set of functionalities that we have at our disposal to use in JavaScript to make such a server request. It's a bit like a clerk at the post office. Say you're bringing a package to the post office and you are the first in the queue. The clerk on the other side of the service desk is JavaScript. Since they can only do one thing at a time, they go through the process of getting your details, measuring the weight of the package, pasting stamps onto the package, charging you for the service, and going to the back office and carrying the package there, then taking time to find the correct place for the package before it gets shipped. The problem with this approach is that the next step cannot start before the previous one is finished. That's what's known as single-threaded execution. Since JavaScript is not at all equipped to multitask, a way to go around this issue is as follows. First, JavaScript gets your details. At the same time, it calls a clerk to measure the weight of the package. Then, JavaScript calls yet another clerk to paste some stamps onto the package. JavaScript calls yet another clerk to charge you for the service, and yet another clerk is called to carry the package to the back office, allowing JavaScript to take care of the next customer. Essentially, this delegation of duties is what's referred to as asynchronous JavaScript. In this metaphor, you can think of the browser as the post office, JavaScript as one clerk in the post office, and all these other clerks can be referred to as browser APIs or web APIs. Now let's explore a practical example of how this delegation of duties works in JavaScript. So I have a local HTML file. The most important part of this file is the script tag, which is getting some JavaScript code from the file named script.js located in the same folder as this HTML file. I'm serving these files locally using the live server VS Code extension. So let me inspect this HTML file in the browser. Okay, so currently it only shows a H1 heading that reads fetching data. Now, let me take a step back and let's say that JavaScript, the post office worker, needs to get some user data from the computer database. Here is the JavaScript code inside the linked to script.js file. What do you expect the output of this code will be, since JavaScript can only do one single thing at any given time? Well, let's explore what the code is doing step by step. On line 1, it performs a console log for the words another customer approaching. Then it contacts the Fetch API, which is a browser API that is external and separate from JavaScript. Rather than waiting for the Fetch API to return the information, it keeps on executing the code that comes after it, outputting the text that begins our valued customer. In the meantime, the Fetch API requests some user data from a third-party web-based API, available at the randomuser.me website. The fetch function is what's known as a facade function, meaning it's a function that looks like it's part of JavaScript, but actually it is just a way for me to call a browser API from JavaScript. In other words, it's a way for me to access a piece of browser functionality that's outside of JavaScript. You can think of it as the JavaScript post office clerk calling the records department of the post office to get some data about a customer. When the other clerk gets back with the information and hands it over to the post office clerk, then they will get a JSON representation and finally will log that data to the console. That means that the sequence of console logs from the code will be as follows. An initial console log that outputs another customer approaching. A second console log that outputs our valued customer. Please wait a moment while I get some information back from the records department. And a final console log that outputs the data. I'll now execute this code to confirm the described behavior. Everything is already saved, so all I need to have this code executed is to go back to the browser, right-click on the page, and press the reload command to refresh it. You can achieve the same result by pressing the F5 key on your keyboard. So now I first get another customer approaching, then the our valued customer, and finally the result of the call to the third-party API. This is how JavaScript, although being single-threaded, can perform asynchronous operations. In this video, you learned how the fetch function works to retrieve data from the web and how to provide an example in plain JavaScript of the process. You should be familiar with this concept before fetching data in React, which I'll explore soon.
The Little Lemon restaurant wants to run a competition for its customers, where a lucky customer will receive a free meal at the restaurant. All customers that are signed up to the Little Lemon app will be entered into the competition, and a random customer will be selected as the winner. In this video, I will show you how to get some random user data from a website. I will be using the random.me website to access random user data for this demonstration. I have prepared some code for this app to fetch the user data from the website. If I execute this code, it will initially output the data pending text in the h1 heading. At the same time, in the background, it will be carrying out the fetch data function to retrieve the user information from the random user website. Notice that I have the DevTools open and the Network tab active. I will click on the No Throttling dropdown to artificially slow down my connection. In the dropdown, I will choose the Slow 3G preset. This is so that I can observe the data pending text in the heading before the data gets fetched from the web. Once the data has been successfully fetched, it updates the view with the data returned h1 heading and the user information that has been retrieved. In this example, the data that was requested was the first name and the last name of this random user. Let's step through this code in more detail. So first, I have the app function, and inside of it, following the rules of hook, I'm invoking the useState hook at the top level of the component. The initial value of the state variable is an empty array. Next, I have defined the fetchData function, which is fetching data from the randomuser.me API. Then it retrieves a response from the API in JSON format. It then updates the state variable with this JSON data. You may notice that I'm not using a hook inside the fetchData function because that's against the rules of hooks. After that, I'm calling the useEffect hook, and from inside the useEffect hook, I'm calling the fetchData function, which I've defined previously. Finally, I'm using conditional logic to decide what to return. First, I'm using the object.keys code snippet to put all the keys of the user object into an array. Since object.keys returns an array, I can access the length property on this array and check if the length of this array is greater than 0. If it is, it means that the contents of the state array has changed, because, as you may remember, the state variable's array was empty. So, if the array is no longer empty, then the div section will be returned with the h1 tag and a couple of h2 tags. Otherwise, the h1 tag below is returned that reads data pending. Sometimes it can take a little bit of time for the fetchData function to retrieve the data requested. Therefore, the data pending message would be displayed initially after the code is executed. Once the data has arrived from the fetchData call, this change in state causes a re-render of my component. So the return statement's ternary operator is re-evaluated, and that returns all the data from my call to the fetch API. And this is essentially how you get data from the web using React. So the Little Lemon restaurant would be able to apply the same logic to their customer list API to select a random winner for their competition. In this video, you have learned how to fetch data using the state and effect hook.
Imagine opening up the landing page of Facebook or Instagram, and all you see is just emptiness, because the things that fills the data in there, the photos and the words and the likes and the comments, all of those things are coming through the API. So writing APIs with integrity, with efficiency, is an important part of the application development process, and without it, you basically don't have an application. My name is Murtada. I'm a software engineer at Meta working in the Seattle office. The design process at Meta for APIs usually involves multiple iterations, just in the same way that when we write code, we get our peers and colleagues to review it. We do the same with API. Somebody or a group of people would usually write a document that's a proposal for how the API would be and what the structure is, what the agreements that each part of the application will make with each other. And then that proposal is usually placed forward. Other engineers will review it. They'll leave comments. They'll say, this makes sense. This needs to be changed. This is not good. And then we iterate, we improve it. And then when the API is looking good, it's in the final stage, we then take it to the next step, which is building it. In the building process, the same thing happens. We're going to review the code that is implementing the design that was created. And there are comments and feedback and iterations. And once that's complete, then we have our API ready. Usually the process of developing an API involves engineers on all ends of the spectrum. So we would be talking to the front-end engineers and the back-end engineers and people working in the middle layer in between as well to make sure that the APIs are consistent and make sense across the entire stack. And basically, if you think about APIs, to just simplify it, it's a way to talk to different things. If you have your mobile phone, you have your application and that you're holding in your hand, it has to talk to the server. And so the way it talks to the server is through an API. So if you want to talk to something, you have to establish some kind of understanding. And that understanding is established between the developers in order for it to be built into the application and reflected in the way that the API is designed. There are a few things we look for and follow when we're designing APIs. One of them is ensuring type safety. So type safety is basically a way to ensure that when you're fetching something from the backend, you're going to get what you're expecting. So if you're requesting a photo, that you actually do get a photo, not a video or something else. So that's an important part of designing API to make sure things don't break. A lot of the application failures happen when there's a mismatch in the data where you fetch something, you expect a certain object, and you get something else. So that type safety ensures these kind of mistakes or problems are minimized, and it increases the stability of an application when you have that consistent type safety across the stack. One of the things that I usually struggle with when designing API is making it such that it'll work for the future. And there's a little bit of a sweet spot to aim for with this, that we can obsess about wanting to make our APIs very compatible with the future and trying to anticipate how the application will evolve and we're going to need this and that and let's bake it in right away. But also sometimes that could be too much. And finding that balance where you think about the future, but not so much such that you're holding yourself back from actually getting the work done. It's just like with everything in life, you try to anticipate, but also you try to also focus on the problem in front of you now and how you can address it effectively. I know APIs can be a little overwhelming at times, so wishing you the best of luck. Take your time to learn them and don't let that overwhelm you or intimidate you. It's okay that when you're looking at APIs, you're going to be venturing into the backend. And so just know that you are taking on more scope and more complexity, and that's going to be good for you because you will become more attractive to employers. You will expand your knowledge. So don't let that intimidate you or hold you back. It's going to be helpful to learn these skills and concepts. The advice that I want to give myself and everybody who's thinking about APIs is to keep it simple. Sometimes we tend to overthink too and try to cram too many things into APIs and try to make it very fancy and very using complicated and complex design patterns. But actually simplicity is really important in API design, and the readability of it is a big plus. So keep it simple and try to keep it stable and free of bugs.
By now, you should have a fairly good understanding of the useState hook and be able to practically apply it to your solutions. However, the useState hook does have its limitations. For example, the useState hook may become cumbersome if you have complex state logic that involves multiple sub-values or when the next state depends on the previous one. In these situations, the useReducer hook can provide a much better alternative. In this video, you'll learn more about useReducer and how it differs from useState. You can think of the useReducer as a superpowered useState. The useState hook starts with an initial state, but the useReducer hook gets a reducer function in addition to the initial state. This is beneficial because the reducer function's second argument is the action object. This object has multiple type values, and based on each of these types values, you can invoke the dispatch function to perform a specific operation. Now, say the Little Lemon restaurant is growing in popularity and demand, and as a result, keeping track of expenses is becoming an issue. So far, they have been calculating the income and outgoings manually as they sell meals to their customers and buy ingredients to replenish the stock. Little Lemon is looking for a solution to this using React in order to keep track of expenses in their app and reduce the burden on their staff. Because using the useState hook would make the solution to this unnecessarily extensive, this is a perfect opportunity to implement the useReducer hook in order to simply keep track of the cost of buying ingredients and the income generated from selling the finished meals to the customers. Now, let's explore how to implement the useReducer hook in a code example to reinforce your understanding. Imagine I am coding the expenses tracking application for Little Lemon discussed earlier using React and useReducer. With this app, I can track two actions: the cost of buying ingredients to prepare the meals in the Little Lemon restaurant and the income from selling the finished meals to the customers in the restaurant. For the sake of simplicity, I've only added two actions: buy ingredients and sell meals. The reducer function takes in the previous state and an action and returns the new state. The action type determines the specific action of the reducer. Actions can have any form. By convention, it's common to pass objects with a type property identifying the action. It should include the minimal necessary information that the reducer needs to compute the next state. You can find out more about extracting state logic into a reducer in the additional readings at the end of this lesson. Instead of using setState like the useState hook, you use the dispatch method of the useReducer hook. This accepts an object literal with a single property called type, set to a matching action.type whose behavior is defined inside the reducer function. As I'm already serving this app in the browser, let me demonstrate how it works. When I press the Shopping for Veggies button, the amount in the wallet decreases by 10, and when I press the Serve a Meal to the customer, the amount in the wallet increases by 10. With useReducer, you can define more types, as many as you need. This way, you can easily work with more complex logic in your React apps, something that might be too difficult to rationalize when using useState. To explore this in practice, let's add another action type. I'll name it Celebrity Visit. This action should be triggered when a celebrity visits the restaurant, which brings in $5,000 to the restaurant when it happens. To make this work, I've added another action type to the reducer function, and then another button to trigger it. I'll save my changes and preview the updated app in the browser. There, it's all working as intended. Clicking the Celebrity Visit button increases the wallet amount by $5,000. And it's as simple as that. Now the Little Lemon restaurant will be able to keep track of their expenses so that they have a clear view of how much profit they're making from their business. In this video, you have learned about the useReducer hook, how it differs from the useState hook, and why it can be a beneficial and more efficient solution in certain circumstances.
Imagine the owner of Little Lemon would like a search inventory functionality that would focus the cursor into the search input field. In this video, I will demonstrate how to code this specific requirement in a separate app so that you can focus on this particular functionality. So here I have another example app built using Create React App, or CRA. Note that for the purpose of this demonstration, I have made some tweaks so that I can more easily showcase the useRef hook. So, my starting app is just a return statement with a fragment, and inside of it, an H1 that reads, using useRef to access the underlying DOM. As I'd like to demonstrate how the useRef hook is used to access the DOM, I will use it to focus the cursor into an input field. So let me start by adding the input field. I will also add a button. Now that I've added an onClick event handling attribute, I need to define the focus input function to handle the button clicks. For the sake of simplicity, my click handler only accesses the form input ref object, and then it accesses the focus method on the current property, which exists on the form input ref object. But what is this object and where does it come from? This object is the return value of invoking the useRef hook. So in this update to my function, I'm invoking the React useRef function and I'm saving a ref object, that is the value returned from that function invocation, to a variable named form input ref. I'm then setting the JSX expression of formInputRef as the value of the ref attribute on the input element. React will create the input element's DOM node and render it on the screen. This DOM node is assigned as the value of the current property of the ref object. This makes it possible to access the input DOM node and all its properties and values using the syntax formInputRef.current. Since I want to access the focus function on the input element's DOM node, I'm using the syntax formInputRef.current.focus. This allows me to move the focus to the input field so that it is ready to be typed into without the user having to click, tap, or tab into it. This is now triggered on a button click. To confirm that this works, I will save all my changes, go to my app being served in the browser, click outside of the input box, and click the Focus Input button. Great, everything is working as expected. You have just learned about using the useRef hook to hook into the DOM and work with the properties of a specific DOM node that you choose based on the task at hand.
Well done. You've reached the end of this module on React hooks and custom hooks. Throughout this module, you've explored hooks in React in depth and covered many important concepts and practical applications that will benefit you as you progress through the course. It's now time to recap the key lessons you've learned and skills you've gained. Your first lesson focused on the useState hook, which is used to work with state in a React component. You explored how to perform array destructuring using the useState hook and update state when using useState through the state updating function, and even how to change state in response to user-generated events like button clicks. You then worked through a detailed demonstration, learning how to use the useState hook within a component, including how to declare, read, and update state. Next, you learned about side effects in relation to another important hook, the useEffect hook. You discovered that side effects make a function impure, with impure functions performing side effects, such as invoking console log, fetch, or the browser's geolocation functionality. In addition to learning about the useEffect hook theoretically, you learned how to use the useEffect hook to perform side effects within functional components and to control when the useEffect function is run using the dependency array through a practical demonstration. Recall that the dependency array determines when the useEffect hook will be invoked. Following the completion of Lesson 1 of this module, you should now be better positioned to work with state in React and to handle side effects in your components. The second lesson of this module focused on the rules of hooks and fetching JSON data from the web. First, you were introduced to the rules of hooks in React and unpacked them. These rules are that you should only call hooks from a React component function and at the top level of a React component function, are allowed to call multiple state hooks or effect hooks inside a component, and should make multiple hook calls in the same sequence. Next, in relation to the fetch function, you learned about the delegation of duties in JavaScript referred to as asynchronous JavaScript. You also learned about the fetch function itself, which is a function that looks like it's part of JavaScript, but is actually a way to call a browser API from JavaScript. This led up to the lesson on fetching data using the state and effect hooks. You worked through a demonstration where a call to the fetch API was used to get data from the web using React. Now that you've completed this lesson, you should have greater insight into what happens if a developer doesn't follow the rules of hooks in React and be able to describe how data is fetched in both JavaScript and React. In the third lesson of this module, you learned about the useReducer hook and that it differs from the useState hook because it gets a reducer function in addition to the initial state. You learned that the useReducer hook could be used in cases where the useState hook would be inefficient, such as when you have complex state logic, and how to implement the useReducer hook in your code. You were also introduced to the concept of refs and how they can be used to go beyond the virtual DOM and access the underlying DOM elements, as well as other applications, and had the opportunity to explore coding your own custom hooks. By completing this lesson, you should be able to use the useReducer hook to track state as well as roll out your own hooks in your React apps. You're making excellent progress. Now that you have a solid grasp of working with hooks, it's time to take a deep dive into JSX, which I look forward to guiding you through in the next module. At this point, you may be wondering how to define what JSX actually is, and it may not be entirely clear how React works with JSX to describe a UI and produce a user-friendly and effective app. Well, let's explore these concepts in a bit more detail. In this video, you'll learn how React uses JSX to describe a UI, the differences between components and elements, and the general concepts behind the React declarative model. The Little Lemon restaurant owners have been happy with their original website for a long time, but as they have grown as a business, they now want to add more features, functionality, analytics, and user interactivity. They are noticing that their original website was built in a way that means there are many limitations when it comes to these types of enhancements. After seeking some advice, they have concluded that they should develop an app using JSX and React. They want to understand more about JSX and React so that they can build a rationale into their business plan. So let's get started with JSX. JSX is a syntax extension to JavaScript that React uses to describe what the UI should look like. However, even though JSX looks like HTML, it's essentially a more powerful abstraction that combines both markup and business logic into an entity called a component. So, what is really happening from the moment you write JSX in your render function until React creates the desired assets for your pages? To understand all the steps involved, you need to be introduced to the concept of elements in React. By now, you already have a good understanding of components and how your entire UI is represented by a tree of them. You also know that the final web pages that React produces are nothing more than pure HTML, CSS, and JavaScript. When React analyzes your rendering methods from all your components, it takes the whole JSX tree starting from the root and creates an intermediary representation. This representation is essentially another tree, similar to before, but where each node, instead of being JSX, is a plain object describing a component instance or DOM node and its desired properties. This plain object is what React defines as an element. An element is just a way to represent the final HTML output as a plain object. It consists primarily of two attributes, type and props. Type defines the type of node, such as a button, and props encompasses all the properties the component receives in a single object. Observe how the elements can be nested, as in the button example, via the children property. When React creates the entire element tree starting from the root element specifies all the child elements as the children prop, and each child element does the same thing until it reaches the end of the tree. What is important about this new structure is that both child and parent elements are just descriptions and not actual instances. In other words, they don't refer to anything on the screen when you create them. They're just objects after all. But these objects are easy to traverse and, of course, are simpler than the actual DOM elements. So far, you have been introduced to an example of a tree transformation with simple DOM nodes, like a button. In the element tree, this is specified as the type property. But the type of an element can also be a function corresponding to a React component. Imagine you have created a component to encapsulate the traditional HTML button named Submit button. In this case, the type property of the element will point to the name of the component. This is the fundamental idea of React. Both user-defined components and DOM nodes can be nested and mixed with each other in the element tree. For example, if you were creating a logout process for the Little Lemon restaurant app, you could do this with a logout component in JSX. In this logout component, the JSX would translate to the following tree of elements. That allows you to mix and match components and DOM elements as the type property without worrying about whether Submit button renders to a button, a div, or something else entirely. This keeps components decoupled from each other, expressing their relationships through composition. When React sees an element with a function type, like the Submit button, it will know to ask that component what element it renders to, with the given props. So React will ask Submit button, again, what it renders to, and it will transform that into an element. React will keep repeating this process until it knows the underlying DOM tag elements for every component on the page. Once React finishes the process of identifying all user-defined components from the tree of elements, it will convert them into DOM elements. The result is what is generally known as the virtual DOM, a JavaScript alternative representation of the real DOM. Now, what are the steps involved when there is a new change in your UI? First, React will take all your JSX and produce a new UI representation as a tree of elements. Second, it will compare it with a previous representation that is kept in memory. Third, it will calculate the difference in a tree. Recall that since each node in the tree is a JavaScript object, this diffing operation is very fast. And finally, based on that difference, it will apply the minimum number of changes to the underlying DOM nodes in order to process the update. And that's it. You are probably starting to appreciate the beauty of the React declarative programming model. In this video, you have learned how React uses JSX to describe a UI, the differences between components and elements, and the general concepts behind the React declarative model. You have also seen that React transforms your JSX into an internal tree of elements, which are just JavaScript objects. And it is that lightweight representation that lets React update your UI in a predictable way while being fast enough for high-performance applications.
So the interesting thing about performance, it's one of these things that you can make it or break it with just one line of change. I mean, of course, sometimes it's possible that in order to improve a performance, you have to rewrite an entire application and start over. But sometimes small changes make a big difference. My name is Murtada. I'm a software engineer at Meta based in the Seattle office. At Meta, we really try to think about the different diversity and the different backgrounds that users come from and what technologies they might be using to access our product. So thinking about performance can make a big difference between gaining a user or losing a user, because if the application is not performing, it's not responsive, it's not fast enough, then people will not use it. So it's a big deal for us to think about performance when we're developing these applications. You know, it's never that our applications are just performant out of the box, and we try to look for the things that can improve their performance. Performance is usually something that we build incrementally, and we get to it by making incremental changes, because we may think that this is not important and it's more exciting to build a new feature. It's more exciting to make something more colorful. And performance is this kind of invisible thing that you may not notice it right away. You may not be able to show it and brag about it, but it's actually really important. And it's an underlying part of the application that without it, you can't really have the applications. You know, one of the things that React does really well, and it's kind of what has made it excel and become so popular, is that it's very efficient in building and rendering a web application. What React does really well is that it localizes the change such that if you need to change a small text, you can only have the work for changing that small text instead of having to re-render the entire page, which could be very costly for a computer to execute. So we try to look for bottlenecks and then go dive deeper into these and see, why is this component so slow? Why is it taking so long? How can we refactor this component to make it faster? Maybe we can delegate some of the computation to the backend so that we're not incurring this cost on the user and the front end. So the engineers and the product managers and the designers, they all use the application while it's being developed as much as possible to be in the shoes of a user and really feel the experience that they're going through when they're using our applications. And then once there's enough confidence that this application is ready, after checking all the boxes in terms of its performance, its stability, its usability, and as well as completeness, then we release it in an alpha stage where there's a small number of users trying it out so we can get some feedback. And as we gain more and more confidence throughout the feedback cycle, then we crank it up to more users until it's completely released. It's a very important part of the requirements for an application to be performant and usable. And in order to achieve that, there are certain design patterns and well-established approaches that engineers have developed over time that have known to work really well and increase performance of applications. So like using memoization or delegating part of the processing to the backend. So I encourage you to look for those and find ways that you can introduce these design patterns in your application.
When designing React components, one of the most important properties developers tend to overlook is the children prop. The children prop, which is a special property all components have, is the foundation for the React powerful composition model. Say the Little Lemon restaurant wants to enable users to have accounts on their app. This would mean processes would need to be built to create, manage, and delete accounts in the app. These types of processes can be constructed simply and efficiently using component composition with children. In this video, you will learn why component composition is so important and how to effectively use and appreciate the children prop. You will also learn about 2 key features of composition, and you'll explore some practical examples that will help you understand how you can leverage it so your components are more robust and reusable. There are 2 main features that enable component composition: containment and specialization. Let's break down these 2 main features now, starting with containment. Containment refers to the fact that some components don't know their children ahead of time. This is especially common for components like a sidebar or a dialog, where they delimit a specific area in your UI to contain other elements. You can think of them also as generic boxes. In case you don't know, a dialog is a type of modal window where the rest of the UI is disabled until the modal is addressed and interacted with. For these component boxes, the recommended approach is to use the children prop to pass children elements directly as their content. Let's explore this with a dialog example. Here, you have a dialog component which acts as the box, taking care of styling the container to make it look like a modal window. By using the children prop, it has become a generic component to which we can provide any valid JSX as children. To illustrate that, the confirmation dialog component has been defined, which uses the dialog component and renders as children, a title, and a description. This example also showcases the second feature of component composition: specialization. Specialization defines components as being special cases of other components. In this example, the confirmation dialog is a special case of dialog. Now that you are familiar with the basics of component composition, let's go ahead and code an application to demonstrate what you've learned. This application has been created with Create React App. Imagine Little Lemon would like to offer an easy way for their users to delete their accounts if they want to. The goal is to build a generic dialog component that will contain a title, a description, and a warning button to make sure users are aware of the action's consequences, all using component composition. I have already created 2 generic components, a button and an alert. The button uses the children prop to specify its text, and the alert is a generic box that renders an overlay in the background and a white modal in the center of the screen. The children prop determines the content of that modal. The first step is to create a warning button using the specialization feature of component composition. For that, I'll define a new component named Delete Button, where I'll render the button component and configure its properties to have a red color and the text Delete. Then I'll go ahead and render the alert component. As it stands, it's just a generic white box or container. This illustrates the second feature of component composition, which is containment. I can customize the content of the box in any way I would like by just providing JSX as its children. To fulfill the requirements of Little Lemon, I'll create a header titled Delete Account, as well as a paragraph to inform the user about the action. I want to state clearly that they will miss out on the chef's delicious recipes if they delete their account, so I'll reflect that in the description. Finally, the last piece is to render the delete button as defined previously. And that wraps it up. In this video, you have learned about a React technique called component composition and why it is so important. You also learned how to embrace the 2 key features of composition: containment and specialization. And you explored some practical examples that helped you to create components that are more robust and reusable using the special children prop. React Children is one of the special props all your components have implicitly. That, along with the React composition model, enables a new paradigm of component design. So far, you have discovered how to leverage this special prop in read mode only, meaning that your components consume it as it is provided. But what if I told you that you can go even further and transform your children's elements in any way, shape, or form? To illustrate, say the Little Lemon restaurant wants a way to visualize a summary of live orders as they come in from customers. What would be really useful for the chefs working in the kitchen is to display each customer order in its own separate row, with the name of the dishes, the amount of each dish, the total price, the time of submission, and the full name of the customer. Well, by using a set of new React APIs that will enhance your component design skills, you will be able to solve this problem for Little Lemon with a smart and efficient solution. Let's start by exploring two of these powerful React APIs, React.clone_element and React.children. In this video, you'll learn how to use both of these React APIs and how they can be used to manipulate the render output dynamically. Let's explore the first of these APIs, React.clone_element, in more detail. This is part of the React top-level API, and it's used to manipulate and transform elements. Top-level API refers to the way you would import those functions from the React package. You can either import React as a global object in the top of your file and access them as methods on that object, or alternatively as a named import. Recall that elements are just plain JavaScript objects that React uses internally to describe what you want to appear on the screen. React.clone_element effectively clones and returns a new copy of a provided element. The first argument is the React element you would like to clone, and the second argument is the props that will be added and merged with the original props passed into the component. Remember that props in React are immutable objects, so you must create a copy of the element first and perform the transformation in the copy. That's exactly what React.clone_element allows you to achieve. This API is useful to allow a parent to perform the following operations: modify children properties, add to children properties and extend the functionality of children components. For example, you could add another prop dynamically to the submit button element illustrated before. Another important top-level API useful for children manipulation is React.children, which provides utilities for dealing with the props.children data structure. The most important method is the map function. React.children.map is very similar to the map function from arrays and invokes a function in every child contained within its children prop, performing a transformation and returning a new element. Don't worry if those APIs still sound a bit confusing. Let's get into some code to give you a better picture. The Little Lemon restaurant is busy receiving live orders. To visualize a summary of those orders, I have been tasked to display each one of them in a row, having a fixed horizontal spacing between each piece of key information. In this application, there is an order that has been submitted for a client, requesting a pizza margherita. Each order contains the name of the dish, amount, total price, time of submission, and full name of the client. I have created a row component that will handle the separation per item. At the moment, it just returns the children as they are provided, so all the items on screen are cramped with no separation. Let's go ahead and use both React.clone_element and React.children.map as the implementation to solve the separation problem. The first thing I'll do is use the children.map function to iterate through each child. So far, I am returning each child as it is, so still no changes on the screen. To implement even horizontal spacing, I am going to add some custom style that will set some left margin in each child except for the first one. In order to specify the amount of space, I will create a new prop called spacing that will be the number of pixels and will use string interpolation to set the margin style properly in pixels. Now that the style is defined, I need to attach it as the style prop in each element. So in the map function callback, I'll return a new copy of the element using React.clone_element. The second argument is what lets you specify the new props. In this case, I'd like to add a new style prop that will merge the previous style. If the element is not the first child, then I'll also merge the child style object that contains the margin left statement. Great. The last step then is to use the spacing property in the row component. Let's set it to 32 pixels. And there you go. Each live order now presents all the information clearly so that chefs don't make any mistakes and cook the wrong pizza. In this video, you have learned about two new APIs, React.cloneElement and React.children.map, providing you with a powerful toolset to manipulate children dynamically with ease. The spread operator is one of the coolest additions to the JavaScript language. Thanks to the spread operator, which is represented by 3 dots, common operations that previously required a bit more code, like cloning an object or array, are now so much simpler. So in this video, you will learn how to use the spread operator in objects, how to spread native properties to DOM components, how to design flexible components, and about the caveats when using the spread operator. Imagine that the Little Lemon restaurant wants to have a simple welcome screen where users can sign up or log in depending on whether they have an account or not. The sign up and log in buttons are in nature very similar, with differences in the text and the action taken when they are clicked. To achieve this implementation, you could define a button component that encapsulates the native HTML button element and uses the same props as its native counterpart. However, a button presents dozens of different properties for customization. Instead of having to specify each of them manually, the spread operator can be used to forward all of them without typing each one manually. React embraces this operator at its core when it comes to props. But before digging deeper, let's refresh what this operator enables for objects in pure JavaScript. The spread operator can be applied to different data types in JavaScript, such as arrays, objects, and even strings. Since React props are just objects, this lesson is going to be focused strictly on the object type. Copying and merging objects are the two main operations you may perform with these operators. For a simple copy of an object, this is the syntax required: curly braces and the 3 dots preceding the object to copy. In this example, order amend represents a last-minute change to the type of pizza ordered by the customer. For merging, first you need to spread the properties from the original object and then provide the new properties to be added or to replace original properties. The property called item has been replaced with the new order information. Great. Now that the preliminaries are covered, let's explore how React uses the spread operator. This order list component example renders an order component. Each order component expects 4 props: an ID, username, item, and price. This first example shows how you might usually do it, passing all the props in the return statement explicitly. However, this can be simplified if you already have the props your order component needs in an object. Here, you can see that only the spread operator is required in the return statement, saving us time by just spreading all the props and avoiding having to type them manually. This pattern allows you to create flexible components, but there are also some caveats you need to keep in mind when using the syntax. Let's explore this in more detail with an example demonstration. In this application, I have created a simple welcome screen for Little Lemon Restaurant, where users are able to sign up or log in, depending on whether they have an account or not. At the top, I have defined a button component that wraps the native button from the DOM. This component expects the same props as its native counterpart, with the addition of the type prop, which is a custom prop that determines the background of the button based on the theme provided. Here is a clear example of using the spread operator to group all the props that belong to the native button and explicitly extract the custom props I have defined for this component and are React specific: type and children. This implementation is clean for developers, since they can provide all the props a native button would expect. The second example is a login button component that renders the custom button component I have created itself. This login button does some pre-configuration by fixating some of the props from the button component, in this case, type and on-click, while still passing the native button props down with the spread operator. Now, the app component renders the two buttons and uses the button component for the sign up and the login button component for login. The buttons are both configured here to send the user to the sign up page, unless they have an account, in which case the login button component's original on-click function will send them to the login page. I have also provided both with an on-click handler to show an alert about the intended action when the button is pressed. However, observe how I have mistakenly provided the same alert message that is used for sign up on the login button component, hence overriding the on-click handler that the login button already defines. Now, can you guess what the message of the alert will be when I click on it? I'll give you a few seconds to think about it. Well, if you guessed logging in, you guessed right. The reason is that, even though I have overwritten the on-click prop in the login button component, its implementation is done in a way that prevents that overriding from happening. Why is that? Because of the order of the spread operator. If I go ahead and spread the props at the end instead, right after on-click, the behavior is different and signing up is output instead. So, what are the main takeaways from this lesson? The spread operator is a great tool that enables the creation of more flexible components, especially when forwarding props automatically to other components that expect them, as well as providing your consumers with a nice component API. However, keep in mind that depending on the order of the spread, the behavior may differ, so you need to be conscious about your decision when it comes to component design. In the example of the login button before, it may make sense to prevent the override of the on-click property, but it may not be the intended case for other props. Well done. I hope you're getting an idea of the multiple benefits that can be gained from using these React tools. When building React applications, you will find yourself creating some generic functionality that is not related to the application's business logic and that is needed in many places. For example, think about managing different permission roles, handling errors, or even logging. They are all required for any application, but are not necessary from the business point of view. This group of functionality is what falls into the category of cross-cutting concerns. In this video, you are going to learn about cross-cutting concerns and why components, despite being the primary unit of code reuse in React, aren't always a good choice for this kind of logic. You will also discover why new patterns were introduced to solve this problem. Excited to learn more? Well, let's get started. Imagine that you are tasked with building the logic to display a list of live orders for the Little Lemon restaurant app. Let's explore how this could be achieved. Here is a valid implementation for a live orders list, where local state is used for storing the current list of orders, and useEffect handles both the subscription and unsubscription to the live data, updating the order's value as soon as a new order arrives. Now, imagine that Little Lemon also needs a place in the application to keep track of the number of users subscribing to its newsletter in real time. This could be a valid implementation for such functionality. Can you identify any similarities between live orders list and newsletter list? They are definitely not identical, since they call different methods on data source and render a different output, but much of the implementation is the same. Upon examination, they both add a change listener to data source on mount, set new state whenever the data source changes, and remove the change listener on unmount. You can imagine that in a large app, the same pattern of subscribing to data source and setting local state with new data will occur over and over again. So far, you have seen that a custom hook to encapsulate that logic is one of the solutions at your disposal. However, that introduces the issue of having to alter the implementation of each component that needs that data, and thus making all of them stateful. So how could you define the subscription logic in a single place, share it across many components, and keep them unchanged and stateless? Well, this is where higher order components are a perfect solution. A higher order component, also known as a HOC, is an advanced pattern that emerges from React's compositional nature. Specifically, a higher order component is a function that takes a component and returns a new component. Whereas a component transforms props into UI, a higher order component transforms a component into another component. In other words, it enhances or extends the capabilities of the component provided. Let's go ahead and examine how the implementation of this reusable subscription logic would look with a higher order component. With subscription is the higher order component that takes the wrapped component you would like to enhance with subscription capabilities, as well as a select data function to determine the type of data you are getting from the data source, in this case, either orders or users. With subscription, then, returns a new component that renders the provided component and supplies a new prop to it, called data, that will contain the most recent list of items from the data source of interest. It also passes other props through to the wrapped component, which is a convention in HOCs. That's the implementation. But how about its usage? In this case, you would define two different components configured with custom parameters, one for live orders and another for newsletter subscribers, all without having to repeat the subscription implementation in either live orders and user list, making this a much more efficient solution. There is still one more pattern for cross-cutting concerns that you will learn about soon, called render props. Great! In this video, you have learned about cross-cutting concerns and why components are not always enough for reusing behavior. You also explored one alternative pattern to encapsulate common behavior in React applications, which are higher-order components.
The Little Lemon restaurant is receiving a spike in visits to their website during the last month due to customers loving some of the special pizzas the chef presented to the public. Despite the success, there are some pizzas that aren't receiving the same level of attention, so they have decided to implement some basic analytics to better understand which are the best sellers and which ones are not being ordered so regularly. For that, they would like to track the mouse position of the visitors when they are in the pizza section so that they know exactly which pictures are capturing people's attention and which ones are overlooked. In this video, I'm going to show you how to implement such functionality by using a higher order component, or HOC, which will be in charge of encapsulating the logic and state to track the cursor position of the visitors. Then I'll showcase two different presentational components that will consume that data and present it in different ways. Are you ready? Let's begin. The little application has been created with Create React App. So far, in the rendering part of the app component, there is a header displaying the title of the restaurant and two components, Panel Mouse Logger and Point Mouse Logger. They both expect a mouse position prop and will return null if that prop is not provided. That's why at the moment they don't render anything at all. You could implement the mouse tracking logic in each component, but recall that it would incur code repetition and duplication of the same logic in two different places. That's why the recommended approach is to use one of the techniques that React provides for encapsulating cross-cutting concerns. In this example, I will illustrate how to do this with an HOC. I will call this HOC with mouse position. The with part of the name is a general convention recommended by React since it expresses the enhancing nature of the technique, like providing a component with something else. Recall that an HOC is essentially a function that takes a component and returns a new component. Let's complete the initial scaffold and return a component that will render the wrapped component provided to the function without forgetting to spread the props it receives so that they're passed through. Great. Now to track the position of the cursor, I would need to define a new piece of local state, which I'll call mouse position for the data and set mouse position for the state setter. The initial state will be an object with two properties, x and y, to define the two-dimensional coordinates on the screen, and I will set both to 0. X equals 0 and y equals 0 represents the top left corner of the screen. Next, I would need to set a global listener in the window object for the mouse move event. Since this is a side effect, I need to perform the subscription and unsubscription logic inside useEffect. Let's go ahead and do that. I will add a new event listener for mouse movement to the window object. For the callback, I will name the function handle mouse position change. That for now doesn't do anything. It's important to remove any subscription when your component unmounts. The way to do that is by returning a function from useEffect and then performing any cleanup needed. In this case, I would have to use the window.remove event listener, passing as arguments the mouse move event and the same callback function as before. To complete the logic and set the state with current mouse position, I need to read that information from the browser event object, which is passed as an argument to the callback. That event object contains two properties that define the coordinates, client X and client Y, so I will assign both of them to the corresponding dimension. And finally, the last step to complete the implementation is to set a new prop called mouse position in the wrapped component to pass that information down to all components that are interested in that data. Great, so now that the implementation of the HOC is finished, let's add the last few pieces to display the mouse position on the screen. To enhance the two components previously defined, panel mouse logger and point mouse logger, I will use the HOC to create two new component versions that will be aware of the mouse position data, and I'll call them panel mouse tracker and point mouse tracker respectively. Finally, I will use the enhanced versions in the rendering part of the app component. Amazing! The requirements are now finalized. If I move the cursor around the screen, you can see two different trackers that display the same information in different ways, one as a panel and the one below as a data point. Well, that's the end of this video. Little Lemon Restaurant now uses this solution to track their pizza-loving customers and have discovered that something was affecting the sales of their pizza Diavola. Guess what? After an employee investigated that particular pizza on the app, they noticed that one of the photos was a bit blurry. Thanks to this little tracking application, they have now taken action and uploaded new high-quality photos, so the next time a customer is exploring the menu, they won't miss the pizza Diavola.
So far, you have learned about a technique called higher order components that is used to encapsulate common functionality. But it's not the only one available to you. For example, you can choose between different eating utensils depending on the type of food you're eating. Some chopsticks for your favorite sushi dish, or a fork for a delicious carbonara. But there's nothing wrong with using a fork for eating sushi. After all, not everyone has learned how to use chopsticks, and it's the tool that makes the job easier that matters. Well, this is also the case when it comes to code reusability. There are several tools you can use to share code between React components, and in this video, you are going to be introduced to a new one, the render props pattern. Say the Little Lemon Restaurant is looking for a way to keep count of all the items it has on the menu. They would like to display this information in the application so they know when they need to replenish stock and to make it easier for customers to see what is or isn't available at any given time. That information is stored on a server, so it would have to be fetched first prior to displaying it. There are various ways to define the fetching logic, like a higher order component. However, render props is also a powerful technique you can leverage to reuse common code. The render props technique is so appropriately named that it's almost self-explanatory. It's about using a prop called render with a particular attribute that it has to be a function. To be more precise, a component with a render prop takes a function that returns a React element and calls that function inside its render logic. For example, a meal provider component could use this pattern. If you remember, a higher order component enhanced a component by providing new props into it. With render props, however, the new props are injected dynamically as the parameter of the function. You may already have recognized some similarities between the two. The end goal is the same, to enhance components without modifying their original implementation. The way in which they inject those new props or enhancements is what differs. To better illustrate this point, let's explore an application that showcases the implementation of a component that uses a render prop. In this example, the Little Lemon Restaurant would like to keep a count of all the desserts and drinks that it has in the menu. That information will need to be fetched from a server that they control and displayed in the application with a single piece of text. The logic for fetching data is one example of a cross-cutting concern. Multiple components may depend on data that lives somewhere else, but you don't want to implement the same fetching logic over and over in every component that needs it, right? This is a good place to use the render props pattern to abstract this functionality. To showcase how it works, I have created a component called DataFetcher, whose only purpose is to fetch data based on a URL. This is one of its props, but it's the second one that should catch your attention, and that's the render prop. I'm not fetching real data in this example, but I have created a mock if-else statement that will return either a list of all desserts or drinks available based on the URL path. As usual, this fetching logic is a side effect that should be placed inside useEffect. Finally, let's move to the return statement. This is the unusual part. The component is returning the result of calling the render function and has no other rendering business. This is what makes it very flexible. Data fetcher only has one purpose, fetching data. And the way they receive it is via the argument in the render function, which is the local state used to store the list of desserts or drinks. It's then up to the developers to decide how they would like to present that data on the screen. Finally, let's explore the two presentational components I have defined to show the number of desserts and drinks available in the menu. The desserts count component uses a particular endpoint to fetch desserts and uses a paragraph element as the render prop, displaying the number of desserts as a single text. The same applies to the drinks count component, with the difference being that it utilizes another URL and instead shows a header element reflecting the number of drinks. Finally, the app component renders both of them, and the results are displayed on the screen. You have learned about another technique you can use in addition to higher order components, which is the render props pattern. Hopefully, now that Little Lemon keeps a live count of drinks, they can replenish their fridge with your favorite refreshments. As the developer for Little Lemon's restaurant application, how could you guarantee that the app you created works as intended? Well, you may choose to rely on your methodical ability to manually interact with all the different parts of the application yourself, ensuring the app is fully functional. However, manually testing every new incremental change you'd like to make is likely to be tedious, error-prone, and time-consuming, especially as your app grows in complexity. That's where automation tests come in. So in this video, you will learn how to write tests properly for your React components. You will achieve this by exploring why testing is important and best practices when creating tests, being introduced to the tools Jest and React testing library for structuring your tests, as well as working through a practical example of testing a component using these tools. Just like factories perform testing of the products they build to ensure that they work as expected, developers need to do the same with their code. A well-designed suite of automation tests is particularly effective in allowing you to discover defects or bugs before delivery to the client. In doing so, testing is important for guaranteeing the quality of the software you develop. Further, by catching bugs before they find their way into a live application, testing reduces the number of user complaints and can ultimately save an organization time and money. Now that you have an idea of why testing is important, what are the best practices you need to keep in mind when writing your tests? The first is that your tests need to avoid including implementation details of your components. React is just a tool, and your final users will have no notion that React exists at all. So rather than dealing with instances of rendered React components, your tests should work with actual DOM nodes. Secondly, the more your tests resemble the way your software is used, the more confidence they can give you. Finally, you also want your tests to be maintainable in the long run. So, as long as you're not changing functionality, any changes in the implementation of the component won't break your tests and slow you and your team down. Now, let's explore the two tools that React endorses to structure your tests, Jest and the React testing library. Jest is a JavaScript test runner that lets you access an artificial DOM called JS DOM. While JS DOM is only an approximation of how the browser works, it is often good enough for testing React components. Jest provides a good iteration speed combined with powerful features like mocking modules, so you can have more control over how the code executes. Recall that mocking refers to something made as an imitation and enables you to replace complex functions from your code with others that are simpler and simulate the same behavior. Mocking features can be used to make sure that your unit testing is standalone. If you'd like to revisit the concept of mocking in greater depth, you can check out the additional resources at the end of this lesson. The second tool is React Testing Library, which is a set of utilities that let you test React components without relying on their implementation details. React Testing Library has been designed to fulfill all the best practices highlighted before, so that you get a well-configured testing environment out of the box and are able to focus on the business logic your tests need to run assertions on. With the theory covered, Let's go ahead and implement a test from scratch using Jest and React Testing Library. When you start a new project with Create React App, you'll already get both Jest and React Testing Library pre-installed by default. Plus, both tools are already pre-configured, and there is an example test file in your root folder called app.test.js. Imagine that Little Lemon has made an agreement with a popular restaurant aggregator to have its web page included as a new URL in its listing. In the app.js file, the app component renders a link in the page that points to Little Lemon's web page. Let's go through the test I created to automatically verify that the link is always present. The first thing I need to do is to import both render and screen from the React Testing Library. The render function is used to render the component you would like to test and perform assertions against. Because querying the entire document.body is very common, React Testing Library also exports a screen object, which is a reference to that object and has every query pre-bound to it, meaning that it will automatically ask the whole document when running a search. Now, to wrap the test scenario, Jest provides the global test function, which takes a text description as the first argument and a function to compose all the steps your test needs to go through as a second argument. This function does not need to be imported, since Jest injects it automatically in all your test files. The first step is to render the app component in the artificial DOM environment. Secondly, I use the screen object to create a query against the document.body. In this case, I am using the getByText utility to ask the body tag of the document if it can find an element inside with a string called Little Lemon Restaurant and store the result of that finding in the link element object. If the search is successful, getByText will return the found element. Otherwise, it will return null. Finally, to complete the test, I perform an assertion asking whether the link element from the query above is present in the document, meaning whether it's currently visible on the screen. For that, the global expect function is used. This is another utility that Jest incorporates globally without the need for an explicit import. The expect function receives the result of a query and appends a specific matcher. In this example, the matcher refers to an element visible in the whole document. If I run the test, it fails. Okay. Let's check the output logs to try to understand what has gone wrong. It states that it was unable to find an element with the text Little Lemon Restaurant. Interesting. Let's go ahead and check the app.js component again. Aha! I had made a mistake and typed orange instead of lemon, something that the test was able to catch. That's exactly what you want to see when a failure occurs. Also, you might have noticed how straightforward it is to write your test assertions. Everything you see in code translates nicely to how a real user would interact with your app and responds with the behavior that you would expect. Let's run the test again now that the issue is fixed. Great! The test passes and Little Lemon's online exposure is about to grow even more. In addition to the importance of testing and testing best practices, you have now learned how to test your React components using Jest and the React Test Library. Stay tuned, because soon you will discover how easy it is to write more complex tests.
Imagine that the Little Lemon restaurant started receiving a few bad reviews from its customers. The problem is that they could not figure out what was wrong and act accordingly, since users only provided a low numerical score, skipping the part of providing additional feedback and passing that information to the chefs. In order to solve that, they've decided to make the comment text box mandatory as long as the score provided by their users is lower than 5 in a scale to 10. Additionally, they would like to shield this new logic with automated tests, so whenever any changes are performed, the test suite would run and be able to catch any potential errors incurred by a faulty update. So the application consists of a feedback form that contains a range input for a numerical score ranging from 0 to 10 and a text box to incorporate additional comments. To satisfy the requirements desired by Little Lemon, the submit button will be disabled if the score is lower than 5, forcing users to add a comment of at least 10 characters. Now let's examine the code. The entry point is the app.js component, where I'm rendering a feedback form component. This component receives a prop onSubmit, which is a function that contains the values of the form as parameters, so that the parent app component can perform the submission. The feedback form represents an HTML form and includes two controlled components via local state, a range input and a text area. There are two pieces to highlight in this component. The first is the button disable logic. IsDisabled is the variable that controls that state and is set to true if the score is lower than 5 and the comment has less than 10 characters. The other important piece is the handleSubmit function, which is hooked into the form onSubmit attribute. When the submit button is clicked, the handleSubmit function will be called. This function itself calls the prop function provided by the parent with the corresponding form values. Well, it's clear that the feedback form component contains all the business logic of interest, so let's go ahead and write a test for the submission logic. The convention for tests is to create them inside a file that has the .test extension. That way, Jest, the test runner, is able to pick them up automatically when you run the test command in your terminal. As I have already written a test scenario, I will now walk you through each line of code so that you understand how the test is structured step by step. The test scenario is checking that users are prevented from submitting the form right away if the score is lower than 5 and there is either no additional feedback or it's too short. First, I create a new mock function with Jest. Recall that a mock function is a special function that allows you to track how a particular function is called by external code. When the feedback form calls the function you provide as the onSubmit prop, you will be able to explore the argument passed in the call. Then, I render the feedback form and pass the mock function as the onSubmit prop. The following steps are needed to locate the range input and fill it with a value. Notice that to find the input, I'm using the screen.getByLabel text and passing a regular expression to match against. Screen is a utility object from React Testing Library that represents the whole page, which basically translates to asking the root document to find a label tag whose text contains the word score, and then return the input element associated with that label. To fill the input with a value, you have to use the fire event utility from React Testing Library and call the change function. While React control components update their state via the onChange prop, React Testing Library follows a slightly different convention, removing the on part and having the update method as lowercase. To simulate the form submission, I have to locate the button element. Observe how I'm using a different query method, getByRole, which looks at elements with a specific role attribute. This will work well since the HTML button already has the button role internally set. To simulate the event, I need to provide two arguments. First, the input element in question, and second, the browser event object, which holds the new value as target.value. To perform a button click, I have to use fireEvent.click. It follows the same convention as before, removing the on side of the prop and having everything in lowercase. Great, the final two statements are the assertions of the test. The first one illustrates an example of an expect matcher that wants to check the opposite by prepending the not before calling the final matcher. What it's asserting is that the function that handles the submission of the form has not been called, which is what I'm expecting when an additional comment has been omitted. Furthermore, I have added a second assertion to make sure the submit button is indeed disabled by using the toHave attribute matcher. And that's it. Well done for reaching the end of this demonstration. In this video, you learned how you can shield your business logic with a few lines of powerful code thanks to the React Testing Library. And what's more important, it has enabled the chef at Little Lemon to finally receive the necessary feedback and make sure all the new pizzas have a bit more extra cheese on top.
So I am passionate about style guides. I actually used to be really bad and really used to dislike them and think like they're not important. But now if I see something that's out of style, I like really notice it, and it's like to me it's very frustrating. So now I take them seriously. My name is Murtada. I'm a software engineer at Meta based in the Seattle office. So a lot of the times people think style guides are silly or useless, and they may not actually give them a lot of value. I see this with a lot of new developers when I'm reviewing their code. A lot of my comments are actually about styling, and it may seem like I'm being annoying or I'm being nitpicky about unimportant things, because following style doesn't functionally change the way code works. It just changes the way the code looks. And so people are like, well, why does it matter? This still does the same thing. But it matters because it makes code much easier to read. It makes code much easier to debug and work with. And this is a big deal because a lot of times when we're writing code, we're not just writing it for ourselves, we're writing it for other people. So paying it up front and taking the time to style your code correctly is really worth it. One of the things we look for in following style guides is to make sure that code is self-documenting. And that really helps so that developers are not taking the time to write comments and being elaborate in explaining things, where if you look at the code, you can understand it and read it, and it documents itself just by the way that variables are named or by the way functions are structured. And that's really important because it removes the burden from the developer to write documentation, and it also removes the burden from other developers to read the documentation. It also makes it easier to fix problems when somebody new is looking at the code. And a lot of the times we write code and then we don't keep writing it or improving it or maintaining it. Somebody else comes. And so it's a service to the people that come after us that we write code in a clean, well-styled way so that when they look at it, they're actually able to understand it easily. At Meta, we have a team or a bunch of teams that are kind of the owners of setting the style guides to make sure the company is following similar or consistent guides across the different code bases. Because style guides are one of those things that could involve different opinions and tastes and different ways to achieve the same thing, we want to be consistent. Even if there's multiple ways to do the right thing, we want to choose one way and stay consistent across our code base, just so that developers are not confused when they look from one part of the code base to another. Everyone at Meta is using or following the style guides that are created and managed by the teams responsible for them. So I'm an engineer developer, and I'm daily following and using these style guides just like everybody else in the company who's writing code. Learning about coding and style guides, it may seem like, why do I need this? And it's actually not that complicated. You need it because it's like an investment. Following these style guides and adhering to them and learning the good style guides will make a big difference in the application, in its stability, usability, readability, as well as anything that you do in the future to improve it, whether you're adding new features or you're fixing a bug. So it may seem like it's the unimportant part of developing and writing software, but it actually makes a big difference if you're writing code for the long term.
Well done. You have reached the end of this module on React JSX, Advanced Patterns and Testing. Let's take a few minutes to review what you have learned so far. You began the module with an in-depth lesson on JSX. You were presented with a distinction between components and elements. You learned that components are functions that take data or props as an input and return a tree of elements as output. You also learned that elements are just plain JavaScript objects that offer a lightweight representation of the DOM and let React update your user interface in a fast and predictable way. Next, you discovered the importance of component composition and the use of the children prop. You were introduced to containment and specialization, the two main properties that component composition has. You learned that containment is a technique that is applicable to components that don't know their children ahead of time, like a dialog or a sidebar, and that it uses the special children prop to pass elements directly as their content. You were also introduced to specialization, a technique that allows you to define components as special cases of other components, like creating a confirmation dialog based on a dialog. Then you moved on to a lesson about manipulating children dynamically in JSX. Here you were introduced to a couple of new React APIs, React.cloneElement and React.children. You learned that React.cloneElement clones and returns a new element, allowing you to manipulate and transform elements directly in your JSX. You also learned that React.children.map is useful for children manipulation, and that when used in conjunction with React.cloneElement, enables a powerful composition model for creating flexible components. You worked through a practical example of those two APIs, where a row component was implemented to separate its children evenly. Finally, you were introduced to the spread operator in React. You learned that the spread operator enables two main operations in objects, copying and merging. You then saw how React uses that operator to spread all the props instead of having to type them manually one by one. Finally, you were presented some practical examples that illustrated how the spread operator allows the creation of flexible components. You then moved on to a lesson on advanced patterns to reusing common behavior. The lesson started with an overview of cross-cutting concerns in React. You learned that cross-cutting concerns refers to generic functionality that is not related to the application business logic and that is needed in many places, like handling errors, authentication, or fetching data. You understood why components, despite being the primary unit of code reuse in React, don't fit this type of logic. After that, you were presented with two techniques for cross-cutting concerns. The first technique you were introduced to was the higher-order component technique, which you learned enables a powerful abstraction for creating cross-cutting concerns. You were also presented with an example of how data fetching can be abstracted using this technique. As part of a practical lesson on higher-order components, you learned that a higher-order component is just a function that takes a component and returns a new one. You were presented with a required code structure to create a higher-order component and examined an application of a higher-order component that handled the position of the mouse pointer on the screen. Then, you learned about the second technique for cross-cutting concerns called render props, which is a special prop you add to your components with a particular attribute of being a function that returns a React element. You discovered that, as opposed to higher-order components, the new props are injected dynamically as the parameters of the function, and worked through a practical example where the render props technique was used to abstract the functionality of fetching data from a server. The module ended with a lesson on component testing using React Testing Library. The lesson began with a comprehensive explanation as to why React Testing Library is the recommended tool for your tests. You learned that to guarantee that your applications work as intended, a suite of automated tests is crucial. You were presented with best practices when it comes to testing, seeing how the React Testing Library has been designed with all of them in mind. Finally, you were introduced to a basic example of a test with Jest, the recommended test runner, and React Testing Library to illustrate the basic scaffolding of a test. The lesson on component testing concluded with a practical application of tests in a real-world example. With this, you learned how well-designed tests can catch errors in your code, providing you with the necessary context to fix them. You also discovered a more complex application that can be easily tested with a few lines of code. Then you were presented with several APIs from React Testing Library, like screen to query on the global document and different query types, like querying by text or querying by role. Lastly, you learned about different matchers for your expectations and assertions, like to have been called for mock functions and to have attribute for attributes in your elements. Fantastic work! Congrats for getting to this point in the course. It's time to use everything you have learned so far and build some amazing applications. In this course, you learned about advanced React. Let's take a few moments to recap the key topics that you learned about. In the opening module, you received an overview of components. During the first lesson, you received an introduction to the course. You discovered how to set up a project in VS Code, and you learned how to make the most of the content in this course to ensure that you succeed in your goals. You then moved on to the next lesson, in which you learned how to render lists in React. In this lesson, you learned how to transform and render list components, create a basic list component, and you learned about keys within list components in React. In the next lesson, you explored forms in React. First, you learned about the differences between controlled and uncontrolled components. Next, you discovered how to create a controlled form component in React, and then had a chance to test your skills by creating your own registration form. In the last lesson, you learned about React context. You explored props and state and how they relate to context. You also learned how re-rendering works with context, and you applied your knowledge to create a light, dark theme switcher. Next, you began the second module, which covered all the common hooks in React and how to build custom hooks. In the first lesson of this module, you got started with hooks. You learned how to implement the useState hook to work with complex data and apply this knowledge to manage state within a component. You also learned about side effects and the useEffect hook. In the next lesson, you moved on to the rules of hooks and fetching data with hooks. You discovered the essential rules of hooks and how to use them effectively in your solutions. You also gained an in-depth explanation on how to fetch data using hooks and tested your skills in fetching data in a practical exercise. In the final lesson of the module, you enhanced your knowledge and skills with advanced hooks. You learned about the benefits of the useReducer hook and how it differs from useState, and how to access the underlying DOM with useRef. You then built your own custom hook, usePrevious. In the third module, you explored JSX in more detail and how to test your solutions. In the first lesson, you took a deep dive into JSX. You gained a more detailed overview of JSX, components, and elements. Next, you explored component composition with children, with its two key features, containment and specialization, and how to dynamically manipulate children in JSX. You had the opportunity to apply your new skills when building a radio group component and were introduced to spread attributes in JSX. In the next lesson, you focused on reusing behavior. You learned about cross-cutting concerns in React and explored higher-order components and how they're used to great effect. You also learned about a specific HOC called render props and used render props to implement scroller position tracking in a solution. In the final lesson of this module, you were introduced to integration tests with React Testing Library. You discovered Jest and the React Testing Library. You wrote test scenarios for a form and were introduced to continuous integration. You've reached the end of this course recap. It's now time to try out what you've learned in the graded assessment. Good luck.
Let's now work through what I've produced, and please, if you find something that inspires you, don't hesitate to incorporate it into your own solution as well. Alright, let's get started. I'm using a UI library, Chakra UI, that offers a preset of styles for your React components. That allows me to avoid worrying too much about CSS and focus on the business logic for my portfolio page. Let's have a quick overview of the whole application. The layout consists of a header that contains links to all my relevant social media accounts and links to the different sections of the page. There are 3 full screen sections: a landing section with a profile picture and a quick description about myself, a project section with a list of all past projects I've worked on, and finally, a contact me section to allow visitors to contact me by filling out a simple form. Finally, there's a footer at the bottom. This application level layout is defined at the entry point, the app.js component. Besides the 2 providers at the top, everything inside the main tag translates to the different UI boxes that I described previously: header, landing section, project section, contact me section, footer, and alert. The alert component plays the role of a global dialog that I can trigger from anywhere in the application using React context. Let's go into each section, top to bottom, starting with the header component. Its rendering section begins to illustrate one of the compelling points from the Chakra UI library. First, Chakra provides you with generic boxes, like box, hstack for horizontal stacks or rows, and vstacks for vertical stacks or columns, that use the special children prop to place their content as you wish using properties such as padding, margin, or spacing. Secondly, Chakra uses props for all CSS styles as well as additional ones like spacing to evenly separate a group of children siblings, or in other words, add similar gaps between them. I'm rendering a list of social icons using the map function, picking as key their URL, which is unique per item. Now, if you examine this rendering, you will find 2 of the core React hooks, useRef and useEffect. Those 2 are used in conjunction to achieve this smooth animation of the header. You can find out more about the implementation details in a further reading. Okay, let's now check the next component, landing section. There's nothing particularly special about this component, it's just a presentational component that encompasses the whole screen height and lays an image and text in the center. Still, there's a great component I created that uses some of the techniques you have learned, the full screen section component. Here's a component that leverages both the children prop and the spread operator. Its goal is pretty simple, to create a full screen container box with 1280 pixels as width, with a specific background color and text color depending on whether the background is dark or light. The spread operator allows you to pass down other layout props to the vertical stack component in case you would need further customization. Next, there is Projects section. This is another presentational component that renders all my featured projects in a grid layout. And finally, I will move on to the star of the show, the Contact Me section component. This is probably the most interesting component of them all, since it implements a controlled form with validation and handles some aspects of internal state. To simplify the form business logic, I have decided to use another library that is well known within the React community, Formic. Formic is the most popular open source form library for React, and it stands out due to its declarative nature, allowing you to spend less time wiring up state and change handlers and more time focusing on your business logic. Looking at the application, I have added 4 inputs: one text input for the first name, another text input for the email, a select input to pick the type of inquiry, and finally a comment text area. To define the configuration of the form, you would have to use the useFormic hook. This hook takes a configuration object that is intuitive and easy to follow. Initial values defines the initial state of the form. OnSubmit is a function that will be executed once users click on the submit button, and validation schema specifies the validation rules for this form on the client side. Formic works very nicely in conjunction with Yup, a library that lets you define your validation in a declarative way using a chain of operators. The hook returns a Formic object that is what you have to use to wire up your inputs with the Formic internal state. Now let's explore the business of rendering. I have grouped each input into a form control component, which is imported from Chakra. For example, the first name has a label, the input itself, and a component to display any error messages occurring for that particular input. The isInvalid prop in the form control determines whether the error message is shown or not. For the first name, it would happen if there is an error according to its validation rules and it has been touched, meaning the user has already focused the input at least once. And the input component, I would have to hook the state and change handlers by using formic.getFieldProps with a value of first name as the parameter, which would have to match the property name used in initial values, and spreading the result, which is an object with all the props you need to connect from Formic. So if I go to the form, focus the first name input, and then blur it, an error message pops up on the bottom with the hint required. Nice, isn't it? The remaining inputs follow a similar pattern, so I won't focus too much on them. Finally, we have the form submission. Remember the onSubmit property from the useFormic hook configuration. That's the function that will be called when the form is submitted. In that function, an API call is performed to the endpoint to submit the form along with the form values. Finally, the useEffect hook listens to changes in the response value, and once the server responds, it will open an alert showing a dialog with a confirmation or an error message. This API call is just a simulation for the purpose of the exercise and is programmed in a way that has a 50% chance of being successful. If the response is successful, the form is reset and cleared using the reset form function from the Formic object. Well, let's explore the form in action. I will fill the form with values, click submit, and voila. Here is the alert. We can try again to show the opposite state. So there you have it. This is one possible solution to the portfolio exercise. I'm really looking forward to seeing which approach you took to complete this challenge.
You've reached the end of this advanced React course. You've worked hard to get here and developed a lot of new skills along the way. You're making great progress on your front-end developer journey, and you should now understand how to use more advanced React features, test your React applications, and use JSX more proficiently. You were able to demonstrate some of this learning along with your practical React skill set in the lab project. Following your completion of this course in Advanced React, you should now be able to render list and form components efficiently in React, demonstrate how context provides a way to share global values between components with a defined API and potential applications, use all common hooks in React and put them to use within your application, and build your own custom hooks. The key skills measured in the graded assessment revealed your ability to understand JSX in depth, use advanced patterns to encapsulate common behavior via higher order components, and render props, write tests for your application, and build a portfolio using React. So, what are the next steps? This Advanced React course has enhanced your knowledge and skills in several key areas. You probably realize that there's still more for you to learn. So, if you found this course helpful and want to discover more, then why not register for the next course? You'll continue to develop your skill set during each of the front-end development courses. In the final lab, you'll apply everything you've learned to build your own fully functional website using React. Whether you're just starting out as a technical professional, a student, or a business user, the course and projects prove your knowledge of the value and capabilities of front-end development. The lab consolidates your abilities with a practical application of your skills. But the lab also has an important benefit. It means that you'll have a fully operational website built using React that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses, you'll receive a certificate in front-end development. These certificates provide globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.